Hello there.
And welcome to the Dozing Explorer.
I'm so glad you have found your way here tonight. I am here to be your quiet guide on a journey into wonder, a companion for your mind as it prepares for rest. There is nothing you need to do, nothing to solve. Just find a comfortable position, close your eyes if you wish, and allow my voice to be a gentle anchor in the soft darkness. Tonight, we're going to drift into the endless, shimmering mysteries of the quantum mind. We won't be taking a class or studying a textbook. Instead, we will simply wander through the strange and luminous landscape where the world of the very small meets the vast inner space of consciousness itself. We will explore the borderlands between the physics of possibility and the architecture of a thought, a place where reality seems to bend and shimmer, becoming something far more intricate than we ever imagined. We will listen to the silent hum of the universe that echoes within our own skulls. We'll consider the idea that the solid world we perceive is built upon a foundation of pure potential, a dance of waves and particles. This is a journey into the profound uncertainty that lies at the heart of all matter, and the possibility that this same uncertainty is the very medium from which our thoughts, our feelings, and our sense of self are born. It is an exploration of the universe looking back at itself through you. And just before we begin our descent into this fascinating world, if these quiet explorations help you unwind, if they provide a sanctuary for your mind, consider liking and subscribing. It is a small, silent gesture that helps other sleepy souls and curious minds find their way to this place of rest too. It ensures our journeys can continue, but for now, all of that can fade away. There is nothing you need to do, nothing to figure out. Your only task is to rest, to breathe. Settle in, breathe deeply, and let the journey begin. Your mind has permission to wander, to drift, and to fall completely asleep whenever it feels ready. A particle can be in many places at once until it is observed. This is one of the foundational ideas of the quantum world, known as superposition. Before we look at an electron, for instance, it doesn't have a single, definite location. Instead, it exists as a wave of probability, a haze of potential positions spread out across space. It is, in a sense, everywhere it could be, all at the same time. Think of it not as a tiny marble, but as a cloud of possibility. The moment a measurement is made, the moment an observation takes place, this cloud of potential instantly collapses into a single, concrete point. It exists as a whisper of pure potential. Your brain contains nearly 86 billion neurons, each a world unto itself. This number is a staggering thing to consider, roughly equivalent to the number of stars in a small galaxy. But the true complexity lies not in the number of these cells, but in their connections. Each neuron can form thousands of links called synapses with its neighbors. This creates a web of such immense density that there are more connections in a single human brain than there are stars in the entire Milky Way galaxy. It is a network of pathways for electricity and chemistry to travel, a living labyrinth where thoughts are born. A galaxy of thought resides within you. The simple act of looking at something can change its fundamental nature. This is called the observer effect, and it is a profound departure from our everyday experience. In our world, looking at a ball doesn't change where it is or how fast it's moving. But in the quantum realm, the act of measurement is an intrusive event. To see an electron, you must interact with it, perhaps by bouncing a photon of light off it. That very interaction imparts energy and alters its state, meaning you can never see the particle as it truly was, undisturbed. The universe, at its most fundamental level, seems to be aware that it is being watched. Reality is a participatory process. Inside your neurons are tiny, hollow tubes that some physicists believe are key to consciousness. These structures are called microtubules. They form the cell's internal scaffolding, its skeleton, giving it shape and structure. But some researchers, most notably Sir Roger Penrose and Stuart Hameroff, have proposed a more exotic function. They suggest these microtubules might be perfectly structured to protect delicate quantum processes from the noisy, chaotic environment of the brain. They theorize that within these protected spaces, quantum computations could take place, giving rise to the richness of conscious experience. They may be the architecture of awareness itself. Two particles, once connected, can remain linked across the entire universe. This phenomenon is known as quantum entanglement. If two particles are created at the same time and interact, they can become entangled, their fates intertwined. Imagine a pair of gloves separated into two identical boxes. Without looking, you send one box to the other side of the galaxy. The moment you open your box and see a left-handed glove, you know instantly that the other box contains a right-handed glove. Entanglement is similar, but for properties like spin. Measuring one particle instantly influences the state of the other. Faster than the speed of light could carry a signal between them, it is a silent conversation across space-time. The feeling of a continuous thought is an illusion created by discrete electrical pulses. Your experience of consciousness feels smooth and unbroken, like a flowing river of awareness. But at the neurological level, it is a different story. Your thoughts are composed of countless individual neurons firing in sequence, sending electrical signals called action potentials. Each firing is a distinct event, a tiny spark. It is the incredible speed and complex orchestration of these billions of discrete sparks, firing in coordinated patterns, that your brain seamlessly weaves together into the rich tapestry of a single, continuous moment. Your mind is a symphony of silent sparks. Empty space is not empty at all, but a shimmering sea of potential particles. We tend to think of a vacuum as the definition of nothingness, but quantum field theory paints a very different picture. It suggests that underlying all of reality is a series of fields, one for each fundamental particle. Even in the coldest, darkest vacuum of space, these fields are not still. They hum with a baseline energy, and from this energy, virtual particles can spontaneously emerge into existence, borrowing energy from the void for a fleeting moment before vanishing again. Nothingness is a canvas for potential. The information stored in your brain is not located in any single neuron. A memory, whether it's the face of a loved one or the feeling of a summer afternoon, is not a single file stored in a single cellular folder. Instead, it is a distributed pattern of connections. A memory exists in the specific way that a vast collection of neurons are wired together, in the strength and sensitivity of their synapses. To recall the memory is to reactivate that unique pattern, causing that specific network of neurons to fire in a harmony that recreates the original experience. A single memory is a ghost haunting 1,000 corridors at once. It is a constellation of connections. A particle can borrow energy from the future to overcome an impossible barrier. This is the strange reality of quantum tunneling. According to classical physics, if you don't have enough energy to get over a hill, you simply can't. But a quantum particle, like an electron, faces a barrier and has a small but real probability of simply appearing on the other side, without ever having had the energy to climb it. It's possible through the uncertainty principle, which allows for fleeting fluctuations in energy. The particle can, in a sense, borrow the energy it needs from the vacuum for an infinitesimally short time, pay it back, and find itself in a new location. It is a leap of faith written into the laws of physics. The patterns of your brainwaves change like the tides from deep sleep to focused thought. Your brain is an electrical organ, and the combined activity of its billions of neurons creates rhythmic electrical pulses that can be measured. These are brainwaves. When you are awake, alert, and focused, your brain produces fast, high-frequency beta waves. As you relax and become drowsy, they slow into calmer alpha waves. Deeper relaxation and meditation bring theta waves, and the deepest, dreamless sleep is characterized by the slow, rolling delta waves. Your entire conscious state is reflected in these electrical tides. They are the rhythmic breath of the mind. Reality, at its smallest scale, seems to be governed by probability, not certainty. For centuries, science operated on the assumption that if you knew all the starting conditions of a system, you could predict its future with perfect accuracy. This is the clockwork universe of Isaac Newton. Quantum mechanics revealed that at the subatomic level, this is not true. The universe is not a clock.
It is a game of chance.
You can never predict the exact outcome of a quantum event, only the probability of each possible outcome. The universe seems to have a fundamental fuzziness, an inherent uncertainty woven into its very fabric. The world is built on a foundation of perhaps. The structure of a neuron resembles the branching pattern of a tree or a river delta. A neuron has a central cell body, but extending from it are intricate branching filaments. The long transmitting fiber is the axon, like a tree's trunk. At its end, it splits into many smaller branches. And on the receiving side are the dendrites from the Greek word dendron, meaning tree. These dendrites form a dense, tree-like canopy that gathers signals from other neurons. This fractal pattern of branching allows each neuron to communicate with an enormous number of others, creating the dense network of the mind. It is nature repeating its most elegant patterns. It is possible that every choice you make creates a branching, alternate universe. This is the core idea behind the many worlds interpretation of quantum mechanics. It attempts to solve the measurement problem, why a cloud of possibilities collapses into one reality. The theory suggests it doesn't. Instead, at every quantum decision point, the universe splits. Every possible outcome happens, each in its own separate parallel universe. In one universe, the particle went left. In another, it went right. This implies an almost infinite number of parallel realities, branching off from one another at every moment. For every quantum event, every possibility is a reality somewhere. The scent of rain is processed by a part of your brain older than human language. Your sense of smell or olfaction is unique among the senses. Signals from your nose travel directly to the olfactory bulb, which is part of the limbic system. This is a very ancient part of the brain, one that evolved long before the neocortex, where conscious thought and language reside. The limbic system is also the seat of emotion and long-term memory. This is why a particular scent can trigger such a powerful, immediate, and emotional memory, bypassing rational thought entirely. It is a direct line to your most primal self. Scent is the language of memory. Light itself behaves as both a wave and a particle, a fundamental paradox of existence. For a long time, scientists debated whether light was a wave, like a ripple in a pond, or a stream of tiny particles. Experiments could be designed to prove either case. The astonishing truth of quantum mechanics is that it is both, simultaneously. This is wave-particle duality. A photon travels like a wave, spreading out and interfering with itself, but it arrives and interacts like a particle, delivering its energy to a single point. Which behavior it shows depends entirely on how you choose to measure it. It is a question that answers itself. Your brain operates on only 20 watts of power, less than a dim light bulb. The most complex object in the known universe, a supercomputer of unimaginable power, capable of creating art, science, and love, performs its miracles with astonishing energy efficiency. A modern supercomputer with comparable processing power might require millions of watts and an entire building to house it and keep it cool. The human brain, however, runs on the power equivalent of a refrigerator light, a testament to the elegant and refined processes of 3 billion years of evolution. It is the universe's masterclass in efficiency. An electron does not orbit a nucleus like a planet. It exists as a cloud of possibility. Early models of the atom depicted it as a miniature solar system, with electrons circling the nucleus in neat, predictable orbits. The quantum reality is far stranger. An electron is not a point-like object following a path. Instead, it is described by a wave function that defines a region of space where the electron is likely to be found. These regions are called orbitals, and they have distinct shapes. Some are spherical, some are like dumbbells, some are even more complex. The electron exists within this entire cloud-like shape all at once. It is a ghost in the machine of matter. Consciousness may not be produced by the brain, but merely received by it. This is a more philosophical and speculative idea, sometimes called the receiver or filter theory. In this view, consciousness is not a local phenomenon created by neuronal activity. Instead, it is a fundamental, non-local property of the universe itself, like gravity or space-time. The brain, with its immense complexity, acts not as a generator, but as a highly sophisticated antenna or receiver, tuning into this universal consciousness and filtering it down into the focused, individual experience of a single self. It suggests that you are not creating awareness, but channeling it. Your mind might be a window, not a lamp. Particles can spontaneously appear out of nothing and disappear just as quickly. The vacuum of space-time, far from being empty, is a place of ceaseless activity. According to the uncertainty principle, energy and time are linked in a way that allows for tiny, temporary fluctuations. A small amount of energy can be borrowed from the void, as long as it is paid back very quickly. This borrowed energy can manifest as a pair of particles, a particle and its antimatter counterpart, which exist for a fraction of a second before annihilating each other and disappearing back into the quantum foam. The void is
Alive with fleeting sparks, a single memory is a symphony of connection.
firing in a precise, unique sequence. To remember the taste of an apple is not to activate a single apple neuron. It is to trigger a vast and coordinated cascade of activity. Neurons in your visual cortex might fire to recall its color and shape. Neurons in your auditory cortex might recall the sound of the crunch. Neurons in your emotional centers might recall how you felt. The memory is the specific, synchronized firing of this entire network, a unique pattern of neural music that plays the song of a past experience. It is an echo played on an orchestra of cells. The uncertainty principle states you can never know both a particle's position and its momentum perfectly. This is a fundamental limit on our knowledge of the universe discovered by Werner Heisenberg. It is not a limit of our instruments, but an inherent property of reality itself. The more precisely you measure a particle's position, the less precisely you can know its momentum, its direction and speed. And the more accurately you measure its momentum, the fuzzier its position becomes. There is a trade-off built into the fabric of existence. The universe holds some of its cards close, refusing to show its entire hand at once. Certainty is a price that cannot be paid. The brain's microtubules are structured in patterns related to Fibonacci numbers. The microtubules that form the internal skeleton of our cells are themselves built from smaller protein units called tubulin. These proteins arrange themselves in elegant spiral patterns around the hollow core of the tube. Intriguingly, the numbers of these spirals often correspond to numbers in the Fibonacci sequence, a famous mathematical pattern found throughout nature. In the arrangement of sunflower seeds, the shape of nautilus shells, and the branching of trees, it is a hint that the same mathematical principles that shape the macroscopic world are also at play in the deepest architecture of the mind. Life's favorite number is written in the scaffolding of the cell. Quantum entanglement has been described as spooky action at a distance. This was the famous phrase used by Albert Einstein, who was deeply troubled by the implications of entanglement. He believed that no influence could travel faster than light, and that the seemingly instantaneous connection between two entangled particles must mean there were hidden variables.
Some pre-existing information that we just couldn't see.
However, experiment after experiment has proven that this is not the case. The connection is real, it is instantaneous. And it remains one of the most profound and unsettling mysteries in all of science. It is a ghost story told in the language of physics. Your perception of time is not constant.
It can stretch and compress.
While the clock on the wall ticks at a steady pace, your internal experience of time is remarkably fluid. When you are engaged in an exciting activity or faced with a sudden danger, your brain processes information more densely, and time can seem to slow down. Conversely, during periods of boredom or routine, time can feel as though it is speeding by, with entire hours disappearing unnoticed. Your brain constructs your sense of time's passage, and this construction is deeply influenced by your emotional and attentional state. Your mind is the architect of its own clock. The vacuum of space has a faint energy, a quiet hum left over from the Big Bang. Even in the most perfect vacuum, far from any star or galaxy, there is a pervasive, low-level energy. This is the cosmic microwave background radiation. It is the afterglow of the universe's creation, a faint light that has been traveling across the cosmos for over 13 billion years. It began as an intensely hot, brilliant light, but as the universe expanded and cooled, this light has been stretched into the microwave part of the spectrum. It is a constant, gentle hiss that fills all of space. It is the oldest echo in existence. Every atom in your body has existed for billions of years, recycled from ancient stars. With the exception of hydrogen and a few other light elements forged in the Big Bang, every other element that makes up you and your world was created in the heart of a star. The carbon in your cells, the oxygen you breathe, the calcium in your bones, and the iron in your blood were all fused together under immense pressure and heat inside stars that lived and died long before our sun was born. When these stars exploded as supernovae, they scattered these newly forged elements across the galaxy, providing the raw materials for new stars, new planets, and eventually, for you. You are made of stardust and ancient light. A quantum leap is not a large jump, but the smallest possible change of state. In common language, a quantum leap means a massive, dramatic change. But in physics, it is precisely the opposite. It refers to an electron in an atom jumping from one specific energy level to another. These energy levels are quantized, meaning they can only have discrete, specific values. An electron cannot exist in between these levels. It must instantaneously leap from one to the next. It is the smallest possible, indivisible step that can be taken within an atom. It is a universe that moves in whispers, not shouts. The brain may use quantum effects to perform calculations faster than any supercomputer. Consider the simple act of catching a ball. Your brain instantly calculates a complex trajectory, accounting for speed, spin, and gravity, and coordinates a precise series of muscle contractions. This is a feat of computation that is still challenging for modern robotics. Some theories propose that the brain isn't calculating these possibilities one by one. Instead, it might be leveraging quantum superposition to explore all possible trajectories simultaneously, collapsing to the correct answer in an instant. It would be a form of computation that works with possibilities rather than certainties. Your mind may be a quantum-powered possibility engine. A single photon of light has no mass and experiences no time. According to Einstein's theory of relativity, as an object approaches the speed of light, time slows down for it from the perspective of an outside observer. For a photon, which travels at the speed of light, time stops entirely. From the photon's own point of view, its creation and its absorption, its journey across billions of light years from a distant star to your eye happens in the exact same instant. For a photon, there is no past or future, only a single, timeless moment of existence. It is a messenger that arrives at the same moment it departs. The feeling of self is a complex construction, a story the brain tells itself. There is no single point in your brain where your self resides. There is no central command module, no little person watching a screen. Instead, your sense of being a unified, continuous self is an emergent property, skillfully woven together from countless disparate processes. Your brain combines sensory input, memories, internal monologue, and future plans into a coherent narrative. This story is constantly being updated and edited to create a stable, consistent character. You. At the quantum level, the distinction between a thing and its information begins to blur. In our world, a book is separate from the story it contains. But for a particle, its properties, like its mass, charge, and spin, are not just descriptions. They are the particle. It is as if the particle is made of pure information. Some physicists, like John Archibald Wheeler, have even gone so far as to propose an it from bit hypothesis. The idea that the physical universe itself emerges from information, that at its base, reality is composed of binary answers to yes or no questions. The universe may be a story that writes itself into existence. Your brain uses 1/10 of all the calories you consume just to think. While it only makes up about 2% of your body weight, the brain is an incredibly greedy organ when it comes to energy. This energy consumption is remarkably stable, whether you are solving a difficult math problem or simply resting with your eyes closed. The vast majority of this power is used to maintain the basic readiness of your neurons, keeping their electrical gradients charged and ready to fire at a moment's notice. It is the cost of keeping a universe of potential thought on standby. It is the quiet hum of a mind ready to awaken. Particles can exist in a state of superposition, being both one thing and another simultaneously.
Imagine a coin spinning in the air.
While it's spinning, it is neither heads nor tails. It is a blur of both possibilities. Superposition is the quantum version of this. An electron spin, for example, can be both up and down at the same time. It isn't that we just don't know which it is. It is that it genuinely exists in both states at once.
Only when a measurement is made does it choose a side.
And the spinning coin of possibility lands on a single, definite reality. Existence itself can be held in suspense. The brain's internal map of the body can be tricked by simple illusions. You have a rich, detailed sense of your own body, a mental model known as the body schema. This map, however, is surprisingly malleable. In the famous rubber hand illusion, a person's real hand is hidden from view, and a fake rubber hand is placed where they can see it. If both the real hand and the rubber hand are stroked simultaneously with a paintbrush, within minutes, the person's brain will adopt the rubber hand as its own. They will feel the sensation of the brush on the rubber hand, a powerful demonstration that our sense of self is a constantly updated construct. Your mind decides the boundaries of you. The universe may be a hologram, with all its information encoded on a distant two-dimensional surface. This is the holographic principle, an idea that emerged from the study of black holes. It was found that the maximum amount of information that can be contained within a volume of space is proportional not to its volume, but to its surface area. This is like saying the entire contents of a library are determined by the number of letters that can be written on its walls. This has led to the speculative idea that our three-dimensional reality might be a projection of information stored on a vast, distant 2D boundary like a complex hologram. We might be living within the image of a deeper reality. Synapses. The gaps between neurons are spaces of pure potential for thought.
Neurons do not physically touch.
Between the axon of one neuron and the dendrite of the next, there is a tiny gap, the synaptic cleft. This is the stage upon which the drama of the mind unfolds. An electrical signal arrives at the end of one neuron, and this triggers the release of chemical messengers called neurotransmitters. These chemicals drift across the gap and are received by the next neuron, either encouraging it or discouraging it from firing its own signal. Every thought, every feeling is a negotiation across trillions of these infinitesimal spaces. The mind is built upon a foundation of empty space, and objects' properties, like its spin or charge, are not set in stone until measured. In the classical world, a ball has a definite spin whether we look at it or not. In the quantum world, this isn't the case. A property like spin exists in a state of potential, a superposition of all possible outcomes. The act of measurement is what forces the universe to commit to a single value. Before the observation, the property is an open question. After the observation, it is a definite answer. Reality, it seems, waits for a question to be asked before it decides on its response. The world is a conversation between the observer and the observed. The process of photosynthesis in plants relies on quantum mechanics to be efficient. When a photon of sunlight strikes a leaf, its energy needs to be transported to a reaction center where it can be converted into chemical energy. The path to this center is a dense, complex forest of chlorophyll molecules. Classically, the energy would have to try path after path, randomly searching for the right one, which would be very inefficient. Instead, photosynthesis uses quantum coherence. The energy exists in a superposition, exploring all possible paths simultaneously and instantly chooses the most efficient route. It is a quantum search algorithm perfected by nature. Even a blade of grass performs a quantum calculation. Alpha waves in a relaxed brain oscillate at the same frequency as the Earth's own magnetic field. When your mind is in a state of calm wakefulness, not focused on any particular task, your brain produces electrical rhythms known as alpha waves, which cycle at about 8 to 12 times per second. Interestingly, the primary resonant frequency of the Earth's magnetic cavity, known as the Schumann resonance, falls within this exact same range at about 7.83 Hertz. It's a fascinating coincidence, a moment where the electrical rhythm of a peaceful mind mirrors a planetary scale vibration. The resting mind is in tune with the rhythm of the planet. Information in the quantum world can never truly be destroyed. One of the fundamental principles of physics is that information is conserved. You can burn a book, but the information in it is not truly gone. It is just scrambled into the configuration of smoke, ash, and heat. The black hole information paradox challenged this idea, suggesting that anything falling into a black hole would have its information wiped from existence. But modern theories are leaning back towards conservation, proposing that the information is smeared out and encoded on the black hole's event horizon, or perhaps released in the faint radiation it emits over eons. A thought, once had, leaves a permanent echo in the cosmos. Your brain rewires itself every single day based on your experiences. This remarkable ability is called neuroplasticity. Your brain is not a static, hardwired machine. It is more like a living, dynamic sculpture constantly being reshaped by your thoughts, actions, and environment. When you learn a new skill, practice a musical instrument, or even just focus your attention on something, you strengthen the synaptic connections involved. Pathways that are used frequently become stronger and more efficient, like well-trodden paths in a forest, while unused connections can weaken and fade away. Your mind is a map that is redrawn by every step you take. Some theories propose that microtubules in neurons can maintain quantum coherence. For a quantum computation to work, the system must be kept in a delicate state of superposition, shielded from the environment. This is called coherence. Any interaction with the outside world causes this state to collapse, a process called decoherence. The warm, wet, and chaotic environment of the brain would seem to be the worst possible place for such a thing. However, the Orcoir theory suggests that the hollow, cylindrical structure of microtubules might act as a natural shield, allowing quantum states to remain coherent long enough to perform the complex computations associated with consciousness. Awareness may be a protected, fragile flame. The arrow of time might be an emergent property, not a fundamental one. The laws of physics at the most fundamental level work just as well forwards as they do backwards. There is nothing in the equations of motion for a single particle that says time must flow in one direction. So why do we experience time as a relentless one-way street? The prevailing theory links it to entropy, the tendency of systems to become more disordered over time. The universe began in a highly ordered state, and its inevitable progression towards disorder is what we perceive as the forward arrow of time. It's not a feature of the mechanics, but a feature of the overall cosmic state. Time may not be a river, but a direction of falling sand. The human eye can detect a single photon of light in a dark room. The sensitivity of our visual system is truly astonishing, pushed to the absolute physical limit. Under conditions of complete darkness, after the eyes have fully adapted, a rod cell in the retina can be triggered by the absorption of a single quantum of light, a single photon. While it takes a few of these single photon events happening in close succession for the brain to register a conscious flash of light, the initial detection happens at the most fundamental level possible. Your eye is a biological instrument capable of registering the smallest possible unit of the electromagnetic world. You can see the indivisible atom of light itself. A quantum bit, or qubit, can hold the values of 0 and 1 at the exact same time. A regular computer bit is a simple switch. It is either a 0 or a 1. A qubit, the building block of a quantum computer, leverages superposition. It can be a 0, a 1, or a blend of both simultaneously. This ability to exist in multiple states at once allows quantum computers to explore a vast number of possibilities in parallel. 2 qubits can hold 4 values at once. 3 qubits can hold 8. This exponential increase in processing power could one day solve problems that are utterly intractable for even the most powerful classical supercomputers. Is a calculation performed in the space between
Answers. The brain contains more
molecular switches than all the computers and
routers on Earth. The synapse.
the tiny gap between neurons is not a simple on-off switch. It is a complex piece of molecular machinery. The receiving side of the synapse is studded with thousands of receptor proteins, each one a tiny switch that can be flipped by a neurotransmitter. The strength of a synapse can be modified in numerous ways, giving it a vast range of possible states. The sheer number of these synapses and the complexity within each one
Creates a computational system of a richness and
subtlety that dwarfs our current digital technology. It is a computer made of chemistry and whispers. The observer effect suggests that reality is a participatory process. In classical physics, the universe is like a movie that plays out whether there is an audience or not. Quantum physics suggests something more like a theatre play that requires an audience to exist. The properties of a particle, its very state of being, seem to be undefined until an act of observation coaxes them into a definite form. This has led some to speculate that the universe does not fully exist in a concrete, determined state without a conscious observer to perceive it. It is as if the cosmos waits for a witness to solidify its own existence. The universe unfolds in the act of being known. The tiny magnetic sense of a robin used for navigation may be a quantum phenomenon. Many birds, including the European robin, can perceive the Earth's magnetic field as a visual pattern, allowing them to navigate during their long migrations. The leading theory for how they do this involves a quantum process called the radical pair mechanism. When light hits a specific molecule in the bird's eye, it creates a pair of entangled electrons. The Earth's magnetic field can influence the spin of these electrons, which in turn affects the chemical reaction they produce. This change is then registered as a pattern.
superimposed on the bird's normal vision. They
See the world through a lens of quantum entanglement. A thought is a cascading electrical storm crossing the vast network of your mind. When a neuron fires, it sends an electrical impulse, an action potential, down its axon. This is not a flow of electricity like in a copper wire, but a wave of depolarization, a rapid exchange of charged ions across the cell's membrane. When this wave reaches the synapse, it triggers the release of chemicals that may cause the next neuron to fire, and the next, and the next. A single thought is a storm front of this electrochemical activity, a self-propagating wave of firing neurons sweeping across the intricate landscape of the brain. It is lightning that carries meaning. All the matter we can see makes up only 5% of the known universe. Everything you have ever seen or touched, every star, every planet, every person, is made of ordinary so-called baryonic matter. But our cosmological measurements tell us this is just a sliver of what's out there. About 27% of the universe is thought to be dark matter, an invisible substance that doesn't interact with light, but whose gravity holds galaxies together. The remaining 68% is even more mysterious. Dark energy, a strange force that seems to be woven into space-time itself, causing the expansion of the universe to accelerate. We are living on a tiny, luminous island in a vast, dark sea. Quantum tunneling allows particles to pass through solid walls. Imagine throwing a tennis ball against a brick wall. It will always bounce back. But if that tennis ball were a quantum particle, like an electron, there would be a small but non-zero probability that it could simply appear on the other side of the wall without ever having broken through it. Its wave function, the cloud of its possible locations, can extend slightly through the barrier. While the probability of this happening with a macroscopic object like a tennis ball is so low, it would likely never happen in the entire age of the universe. It is a routine and essential event for subatomic particles. The laws of physics allow for the occasional. Quiet miracle dreams may be the brain's way of running simulations of possible futures. While you sleep, particularly during the REM stage associated with vivid dreaming, your brain is highly active. One theory about the purpose of dreaming is that it is a form of threat simulation. Our ancestors could dream about dangerous scenarios, being chased by a predator, for instance, in a safe environment. This would allow them to rehearse their responses and coping strategies without any real-world risk. Dreams, in this view, are a kind of virtual reality training ground, a nightly flight simulator for navigating the challenges of life. Your mind practices living while the body is still. The future can, in a quantum sense, influence the past. This is the mind-bending implication of experiments like the delayed choice quantum eraser. In these experiments, the choice of how to measure a particle seems to retroactively determine the path it took to get there. It is as if a decision made now can reach back in time to alter a past event. This doesn't mean we can send messages to the past and create paradoxes, as the results are only visible after all the information is gathered. But it does challenge our fundamental linear understanding of cause and effect, suggesting a far more holistic and interconnected relationship between past, present, and future. Time's arrow may be a two-headed serpent. The glial cells in your brain, once thought to be simple support structures, are vital for thought. For a long time, neuroscience focused almost exclusively on neurons. The other cells in the brain, the glial cells, which outnumber neurons, were thought to be mere glue, the meaning of glia, providing structural support and cleaning up waste. We now know they are active participants in brain function. They wrap around synapses, control the levels of neurotransmitters, and communicate with each other in their own chemical language. They are not the supporting cast. They are co-stars in the performance of the mind. The stage itself is a part of the play.
Matter is mostly empty space held together by invisible forces.
The nucleus of an atom is incredibly tiny. If you were to scale up an atom to the size of a sports stadium, the nucleus would be a small marble in the center. The electrons would be specks of dust whirling around in the outermost seats. The rest of the stadium would be entirely empty space. The feeling of solidity you experience when you touch an object is not due to matter bumping into matter. It is the electromagnetic force of the electron clouds in your hand repelling the electron clouds of the object. Solidity is an illusion created by force fields. You are made of emptiness, bound by invisible threads. The Penrose-Hameroff-Orr theory links consciousness to vibrations in microtubules. This theory, mentioned earlier, goes into greater detail. It proposes that the tubulin proteins within microtubules can exist in a superposition of two different shapes. These quantum states are linked to the vibrations of the microtubule, like the notes played on a flute. The theory suggests that when these vibrations reach a certain threshold, a moment of orchestrated objective reduction, OR, occurs. This is a self-collapse of the wave function, which Penrose argues is a non-computable physical event. Each such event, the theory claims, constitutes a single moment of conscious experience. Consciousness may be the music of the cellular skeleton. A particle's wave function contains all possible information about its future states. The wave function is the central mathematical object in quantum mechanics. It is a complete description of a quantum system. It doesn't tell you where the particle is, but it tells you the probability of finding it at any given location. It doesn't tell you what its momentum is, but it tells you the probability of measuring any particular momentum. The evolution of this wave function over time is perfectly predictable, governed by the Schrödinger equation. The uncertainty enters only when we perform a measurement, forcing this wave of possibilities to collapse into a single
reality. The future is a wave of potential before it
breaks on the shore of the present. Your mind can process images seen for as little as 13 milliseconds. The speed at which the brain can grasp the meaning of an image is far faster than previously believed. In experiments, subjects were shown a series of images flashed before their eyes, each for a tiny fraction of a second. Even at speeds as fast as 13 milliseconds per image, they were able to identify what they had seen, such as a smiling couple or a picnic. This suggests that the brain's visual processing system is incredibly efficient, performing complex recognition tasks almost instantaneously, long before you have time for conscious, deliberate thought. The speed of sight outpaces the speed of thought. The laws of physics may be different inside a black hole. A black hole is formed when matter is crushed to an infinitely dense point called a singularity. At this point are two great theories of the universe: general relativity, which describes gravity and the very large, and quantum mechanics, which describes the very small, break down. They give nonsensical answers. To understand what happens at the heart of a black hole, we would need a unified theory of everything, or quantum gravity. Without it, the conditions inside are a complete mystery. It is a place where our current understanding of reality comes to an end. It is a point where the map of the universe is marked. Here be dragons. The feeling of intuition might be the brain processing information too quickly for conscious awareness. That gut feeling or sudden flash of insight that seems to come from nowhere is not necessarily mystical. It may be the result of your brain's massive parallel processing capabilities. Your mind is constantly absorbing and processing vast amounts of information from your senses and memories, far more than you are consciously aware of. Intuition may be the moment when this subconscious processing reaches a conclusion, delivering the answer to your conscious mind without showing any of its work. It's pattern recognition happening below the surface of awareness. It is the whisper of your own hidden knowledge. Every electron in the universe is utterly identical to every other electron. This is a profound and strange fact of quantum physics. Unlike macroscopic objects like grains of sand, which are all unique, fundamental particles are truly indistinguishable. Every electron has the exact same mass, the exact same charge, the exact same spin. You cannot label them or tell them apart. This has led to the bizarre one-electron universe hypothesis proposed by John Wheeler, that perhaps there is only one electron in the entire universe, weaving backwards and forwards through time, appearing as the countless electrons we observe at any given moment. All are but reflections of a single, perfect form. The brain's plasticity means it is constantly being sculpted by thought itself. The principle of neuroplasticity, neurons that fire together, wire together, has a powerful implication. Your own patterns of thinking can change the physical structure of your brain. If you consistently focus on gratitude, you can strengthen the neural circuits associated with positive emotions. If you dwell on worry, you strengthen the circuits for anxiety. This means that the act of thinking is not a passive process. It is an active process of creation. You are, in a very real sense, the architect and sculptor of your own mind. Your thoughts are the chisel that shapes the stone of your brain. Quantum mechanics suggests that at its base, the universe is not a machine, but a collection of possibilities. The classical Newtonian worldview was that of a great cosmic machine, a clockwork universe that once set in motion would unfold with perfect, deterministic precision. Quantum mechanics replaced this with a world of inherent fuzziness and potential. At its heart, the universe is a dance of probabilities and potentialities. Things are not determined until they are observed. This paints a picture of a more dynamic, open, and less predictable cosmos, one where possibilities seems to be more fundamental than actuality. Reality is not written in stone, but in a cloud of shifting probabilities. The average human brain generates about 50,000 thoughts per day. This number is an estimate, of course, as defining and counting a thought is notoriously difficult. But it speaks to the relentless, ceaseless activity of the mind. From the moment you wake to the moment you fall asleep, your brain is a cascade of ideas, worries, memories, and plans. Many of these thoughts are fleeting and repetitive, background noise in the theatre of the mind. But this constant stream of mental weather is the very essence of our subjective experience, the internal river in which we live our lives. The mind is a sky in constant motion. An antiparticle is a mirror image of a particle with an opposite charge. For every fundamental particle of matter, there seems to be a corresponding antiparticle. The antiparticle of the negatively charged electron is the positively charged positron. They have the exact same mass but opposite properties. When a particle and its antiparticle meet, they annihilate each other in a flash of pure energy, a perfect conversion of mass into light according to Einstein's famous equation, E(mc)2. One of the great mysteries of cosmology is why the universe seems to be made almost entirely of matter, with very little antimatter to be found. For every note in the symphony of existence, there is a corresponding silence. The brain does not see. It interprets electrical signals sent from the eyes. The experience of sight feels direct and immediate, as if you are simply looking out a window at the world. But the physical process is far more indirect. Light enters your eye and is focused on the retina, where specialized cells convert the photons into electrical signals. These signals, which contain no light or color in themselves, travel down the optic nerve to the back of your brain. It is there, in the visual cortex, that this raw data is processed, interpreted, and constructed into the rich, three-dimensional, colorful world you perceive. Your reality is a sophisticated reconstruction. You are not looking at the world. You are looking at your brain's model of the world. A quantum field pervades all of space-time, and particles are just excitations in this field. Quantum field theory is our most modern understanding of particles. It posits that the most fundamental components of the universe are not tiny, discrete objects, but invisible, fluid-like fields that permeate everything. There is an electron field, a photon field, a Higgs field, and so on. What we perceive as a particle, like an electron, is simply a localized vibration or excitation in its corresponding field, like a ripple in a pond. When particles are created and destroyed, it is just energy being added to or taken from these underlying fields. The universe is a silent ocean, and particles are its momentary waves. The hippocampus is responsible for converting short-term experience into long-term memory. Located deep within the temporal lobes of your brain, this seahorse-shaped structure acts as a kind of memory gatekeeper. Your immediate experiences and sensations are held as short-term memories for a few moments. The hippocampus is crucial for the process of consolidation, where these fleeting experiences are analyzed, indexed, and filed away for more permanent storage in other parts of the cerebral cortex. Without a functioning hippocampus, you could live perpetually in the present moment, unable to form new lasting memories of your life. It is the loom that weaves the threads of moments into the tapestry of your past. The act of forgetting is as important for a functioning mind as the act of remembering. We often think of forgetting as a failure, but it is an essential, active process that allows the brain to operate efficiently. A mind that remembered everything with perfect clarity would be overwhelmed with trivial and useless information. Forgetting helps to prune away irrelevant details, allowing you to generalize from experience and see the bigger picture. It clears away old, outdated information to make room for new learning. A healthy memory is not just about storage, it is about the selective and strategic curation of what is worth keeping. Forgetting is the mind's way of tidying up. It is theorized that the brain emits ultra-weak light signals called biophotons. All living cells, including neurons, seem to emit a very faint glow of light, 1,000 times weaker than what the naked eye can see. These emissions, known as biophotons, are thought to be byproducts of metabolic chemical reactions. While their function is still a subject of intense research and debate, some scientists have speculated that this internal light could be a form of cellular communication. It's possible that the neurons in your brain are communicating not only with electricity and chemicals, but also with their own subtle internal aurora. Your thoughts may have their own faint, inner light. The Pauli exclusion principle is why two objects cannot occupy the same space. This is a fundamental rule of quantum mechanics that applies to a class of particles called fermions, which includes electrons, protons, and neutrons, the building blocks of matter. The principle states that no two identical fermions can occupy the exact same quantum state at the same time. It is this principle that prevents the electron shells of atoms from collapsing into each other. It is the reason that matter is stable and that you cannot pass your hand through a solid table. It is the ultimate source of the world's structure and solidity. It is the universe's simple rule of no duplicates allowed. Your sense of balance is orchestrated by tiny crystals in your inner ear. Deep within your ear, separate from the structures for hearing, is the vestibular system. It contains tiny canals filled with fluid and lined with microscopic hairs. As your head moves, the fluid sloshes around, bending these hairs and sending signals to your brain about your orientation in space. Also within the system are small chambers containing otoliths, which are tiny crystals of calcium carbonate. The pull of gravity on these minuscule stones is what tells your brain which way is down, providing your fundamental sense of up and down. Your body navigates the world with its own internal compass and stones. A quantum computer could, in theory, solve problems that would take a normal computer billions of years. Certain types of problems, like factoring very large numbers or simulating the behavior of complex molecules, have a computational complexity that grows exponentially. For classical computers, these problems quickly become impossible. But because a quantum computer can use superposition and entanglement to explore a vast number of possibilities at once, it could tackle these specific, monumental tasks with relative ease. This could revolutionize fields like medicine, materials science, and cryptography. It is a key designed to unlock a new class of impossible doors. The brain's default mode network is active when you are daydreaming or letting your mind wander. When you are not focused on a specific, external task, your brain is far from idle. A specific network of brain regions, known as the default mode network, becomes highly active. This network is associated with self-referential thought, thinking about yourself, recalling memories, imagining the future, and considering the minds of others. It is the neural substrate of your inner world, the system that constructs your narrative self, when your attention is turned inward. It is the resting state of the mind, which is a state of constant, quiet storytelling. It is the engine of your daydreams. The very substance of reality may be woven from information. This is a modern evolution of the it from bit idea. Instead of thinking of particles and fields as the most fundamental things, some physicists now believe that information is the true bedrock of reality. In this view, things like energy, matter, and even space-time are secondary, emergent properties of a more fundamental, information-theoretic reality. The universe, then, is less like a great machine and more like a great computation, with the laws of physics being the algorithm it is running. Existence itself might be the output of a cosmic program. Neurotransmitters fit into their receptors like a key into a lock, a molecular recognition event. When a chemical messenger like dopamine or serotonin is released into a synapse, it drifts across the gap and finds its corresponding receptor protein on the other side. Each receptor is a complex, three-dimensional molecule with a specifically shaped docking site. Only a neurotransmitter with the correct complementary shape can bind to it, like a key fitting into a lock. This binding event is what changes the receptor's shape and opens an ion channel, passing the signal along. It is a moment of precise molecular choreography. Thought is a conversation spoken in the language of shapes. The double-slit experiment is the quintessential demonstration of quantum mystery. In this experiment, a beam of particles, such as electrons, is fired at a barrier with two small slits in it. If you close one slit, the electrons that pass through the other create a simple pattern on a detector screen behind it. But if you open both slits, the electrons create a complex interference pattern, a series of bright and dark bands as if they were waves that passed through both slits at once and interfered with themselves. The mystery deepens when you try to watch which slit each electron goes through. The very act of observation destroys the interference pattern. It is the experiment that contains all the strangeness of the quantum world. A single human cell contains 2 meters of DNA, intricately folded. The blueprint for your entire body, your DNA, is an incredibly long molecule. If you were to stretch out the DNA from a single cell, it would be about as tall as a person. To fit this immense library of information inside a microscopic nucleus, it must be packaged with astonishing efficiency. The DNA is first wrapped around proteins called histones, like thread around a spool. These are then coiled into thicker fibers, which are looped and coiled again and again, an incredible feat of biological origami that allows a vast amount of information to be stored in a minuscule space. It is a library the size of a city, folded into a grain of sand. The concept of now is not a universal constant. It is relative to the observer. Einstein's theory of special relativity showed that space and time are interwoven into a single fabric, space-time. It also showed that there is no universal now that everyone in the universe agrees upon. 2 events that appear simultaneous to one observer may happen at different times for another observer who is moving relative to the first. Your personal experience of now is just one slice through this 4-dimensional space-time, and other observers will have their own different slices. The present moment is a personal, not a universal, phenomenon. The now is not a single page in the book of the universe, but your own personal bookmark. Anesthesia may work by disrupting quantum processes within neurons. How general anesthetics produce a reversible loss of consciousness is a long-standing medical mystery. They are a diverse group of molecules, and it's unclear what they have in common. The Ochoa theory offers a potential explanation. It suggests that anesthetic molecules, due to their specific quantum properties, are perfectly suited to lodge within the brain's microtubules and dampen the quantum vibrations that are proposed to be the basis of consciousness. In this view, anesthesia doesn't just put the brain to sleep. It temporarily stops the quantum music of the mind. It is a pause button for the symphony of awareness. The universe is expanding, and the expansion is accelerating. In the 1920s, Edwin Hubble discovered that distant galaxies are all moving away from us, and the farther away they are, the faster they are receding. The entire fabric of space-time is stretching. More recently, in the late 1990s, astronomers were shocked to discover that this expansion is not slowing down due to gravity, as expected.
It is speeding up.
This acceleration is attributed to the mysterious dark energy that seems to be pushing space-time apart, a discovery that implies a strange and lonely ultimate fate for our cosmos. The cosmos is a breath that is still being exhaled. The brain edits your sensory input, removing extraneous data to build a stable reality. Your senses are constantly bombarded with far more information than you could possibly process consciously. Your brain acts as a masterful editor. It filters out predictable or unimportant information, such as the feeling of your clothes on your skin or the constant hum of a refrigerator. It also fills in gaps like the blind spot in each of your eyes where the optic nerve connects, seamlessly papering over the missing information so you perceive a complete image. The stable, continuous world you experience is a heavily edited and curated production. Your reality is the final cut of a film with countless discarded scenes. Virtual particles flicker in and out of existence, mediating the fundamental forces. The forces of nature, like electromagnetism, are described in quantum field theory as being carried by messenger particles. For instance, the electromagnetic force between two electrons is communicated by the exchange of virtual photons. These are not real, long-lived particles, but temporary fluctuations in the quantum field that borrow energy from the vacuum for a fleeting moment to carry a message of repulsion or attraction. All the pushes and pulls that hold the world together are, at a fundamental level, a constant exchange of these ephemeral, ghostly messengers. The world is held together by particles that barely exist at all. The brain's predictive coding model suggests you are constantly hallucinating your reality. According to this influential theory, the brain is not a passive receiver of sensory information. It is a prediction engine. It constantly generates a model of the world, a kind of controlled hallucination based on your past experiences and expectations. Sensory information from your eyes and ears is then used not to build reality from scratch, but to check and correct this internal model. What you perceive as reality is actually your brain's best guess about the causes of its sensory input, a guess that is only updated when there is an error between the prediction and the reality. You are not seeing the world. You are seeing how your expectations were wrong. The Casimir effect shows that two uncharged plates in a vacuum will attract each other. If you place two perfectly smooth uncharged metal plates very close together in a perfect vacuum, they will be pushed towards each other by an invisible force. This is the Casimir effect. The explanation lies in the sea of virtual particles in the quantum vacuum. The tiny space between the plates restricts which virtual particles can pop into existence, meaning there are fewer of them between the plates than there are outside. This creates a pressure imbalance, with the greater number of particles on the outside pushing the plates together. It is a force created from the subtle pressure of nothingness. Your neurons fire in synchronized waves, creating the rhythm of your conscious state. Individual neurons firing are like single instruments playing a note, but consciousness seems to arise from the synchronized firing of vast ensembles of neurons like an entire orchestra playing in harmony. These synchronized oscillations are the brain waves we can measure. It is thought that this rhythmic, synchronized activity is how the brain binds together different aspects of an experience, the color, shape, and sound of a bell, for instance, into a single, unified perception. Consciousness is the rhythm that emerges from the chorus of countless neural voices. It is the resonance of a billion minds thinking as one. A particle does not have a definite path. It takes all possible paths at once. This is another strange insight from the double-slit experiment, formalized by Richard Feynman's sum over histories approach. To get from point A to point B, a quantum particle, like an electron, does not follow a single straight line. Instead, it simultaneously explores every possible path it could take: straight paths, curved paths, paths that go all the way to the moon and back. The final probability of it arriving at point B is calculated by adding up the contributions of all of these infinite possible histories. The world we see is just the sum of all the things that could have been. Reality is the consensus of infinite possibilities. The structure of water molecules inside a cell is more ordered than previously thought. Water is not just a passive solvent inside our cells, it is an active participant. The water molecules that surround proteins and other biological structures form ordered, gel-like layers. It's been proposed that these layers of structured water are essential for the proper folding and function of proteins. Some researchers have even suggested that these ordered water molecules could help maintain quantum coherence within the cell, acting as a kind of biological signal amplifier for delicate quantum effects. The water of life has a memory and a structure of its own. The brain's two hemispheres, while specialized, are in constant communication. The popular idea of being left-brained, logical, or right-brained, creative, is a vast oversimplification. While it's true that some functions, like language for most people, are predominantly handled by one hemisphere, the two halves of the brain are in a constant, high-speed dialogue. This communication happens via a massive bundle of nerve fibers called the corpus callosum. The seamless, unified nature of our conscious experience is a testament to the remarkable integration and cooperation between these two distinct but deeply connected hemispheres. Your mind is a conversation between two versions of yourself. The concept of spin in quantum mechanics is a purely mathematical property with no classical analog. We talk about an electron spin being up or down, which conjures an image of a tiny spinning ball. But this is just a helpful and ultimately misleading analogy. Quantum spin is an intrinsic form of angular momentum that a particle possesses, but it doesn't actually correspond to it physically spinning. One of its strangest properties is that you have to rotate an electron a full 720 degrees, 2 complete turns to get it back to its original state. Something that is impossible for any object in our everyday world. It is a property that can only be described by the language of mathematics. Déjà vu might be a momentary delay in the brain's processing pathways. That uncanny feeling of having experienced a new moment before is still not fully understood, but one leading neurological theory suggests it's a brief processing glitch. Information from our senses travels to the brain via multiple pathways. Déjà vu could occur when there is a tiny delay in one of these pathways. Your brain receives one signal a millisecond before the other. The slightly later signal is then processed not as new information, but as a memory of the first, creating a brief, false sense of familiarity. It is an echo of the present moment. Arriving a heartbeat too late, the fine structure constant is a number that seems perfectly tuned for life to exist. This number, approximately 1137, is a fundamental constant of nature that determines the strength of the electromagnetic force. If it were even slightly different, the universe would be unrecognizable. A smaller value and atoms might not be stable. A larger value and stars might not be able to form the heavy elements necessary for life. The fact that this and other physical constants fall within the incredibly narrow range required for a complex, life-supporting universe is known as the fine-tuning problem, a deep mystery that has led to much scientific and philosophical debate. The universe is balanced on a knife's edge of possibility. The direction of a particle's spin is not defined until it is measured. Much like position or momentum, a particle's spin exists in a superposition of states before measurement. If you have a device that can measure spin along a vertical axis, the electron will be forced to choose between up and down. If you then measure its spin along a horizontal axis, it will be forced to choose between left and right. But if you then go back and measure its spin on the vertical axis again, it will have forgotten its original state. The very act of measuring one property can completely randomize another. A quantum question erases the previous answer. Some memories are stored not in the strength of synapses but in their physical structure. While the strengthening and weakening of synapses is a primary mechanism of memory, recent research suggests another, more permanent method of storage. Long-term memories may be encoded in the physical growth of new synaptic connections. When a powerful memory is formed, the brain may physically build new dendritic spines, the tiny protrusions on a neuron that receive signals. This creates a lasting structural change in the neural circuit, a physical engram of the past experience. Memory can be a path that is not just worn, but newly built. The holographic principle suggests our three-dimensional world could be a projection. This idea, which sounds like science fiction, arises from the mathematics of black holes and string theory. It suggests that all the information that makes up our perceived 3D reality is actually encoded on a two-dimensional surface at the edge of the universe. In this view, we are like the characters in a hologram. While we perceive depth and dimension, the information that creates us is fundamentally flat. It is a profound rethinking of the nature of space and information itself. The world may have one less dimension than it appears. The prefrontal cortex is responsible for planning, decision-making, and personality. Located at the very front of your brain, just behind your forehead, the prefrontal cortex is the brain's executive suite. It is responsible for what are called executive functions, orchestrating your thoughts and actions to achieve goals, predicting the consequences of your actions, managing social behavior, and differentiating between conflicting thoughts. It is the part of the brain that is most responsible for your personality and your sense of self-control. It is in many ways the conductor of the orchestra of your mind. It is the part of the brain that thinks about the future. A single water molecule exhibits strange quantum effects, like being in two places at once. Even in something as familiar as water, quantum mechanics is at play. Using sophisticated techniques, scientists have been able to observe a single water molecule tunneling through an energy barrier. They've also found that under certain conditions, the hydrogen atoms in a water molecule can exist in a superposition of two different spin states simultaneously. These subtle quantum phenomena, happening constantly in every drop of water, are essential to its unique chemical and physical properties. Even the most common substance is a stage for quantum theater. The brain filters out predictable sensory information so you can focus on what is new. This process is called sensory adaptation. It is why you quickly stop noticing the feeling of a chair beneath you or the constant ticking of a clock. Your brain's sensory systems are tuned to detect change. They learn what is constant and predictable in your environment and simply stop reporting it to your conscious awareness. This allows your limited attentional resources to be directed towards things that are new, different, or potentially important. It is a vital mechanism for preventing sensory overload. Your mind learns to ignore the constant to notice the fleeting. The standard model of particle physics describes 17 fundamental particles. This is our current, best tested theory of the fundamental building blocks of the universe. It describes 12 particles of matter organized into quarks and leptons, which include the familiar electron. It also describes 4 particles that carry the fundamental forces, such as the photon, which carries electromagnetism. And finally, there is the Higgs boson, the particle associated with the Higgs field, which gives other particles their mass. This elegant but incomplete model successfully describes almost all experimental results in particle physics. It is the current cast of characters in the play of existence. Your brain's software is inseparable from its hardware. In a computer, the software, the code, is distinct from the hardware, the circuits. You can run different programs on the same machine, but in the brain, this distinction breaks down. The brain's software, your memories, skills, and personality, is encoded in its physical hardware, the structure and strength of its synaptic connections. Learning something new is not like loading a new program. It is like physically rewiring the computer. The processing of information and the storage of information are one and the same process. The story is written into the substance of the pages themselves. A quantum system can remain in a coherent state of superposition until it interacts with its environment. This delicate state of existing in multiple possibilities at once is known as quantum coherence. It is the basis for all the strangeness and power of the quantum world. However, coherence is incredibly fragile. Any interaction with the outside world, a stray photon, a vibration, a change in temperature, provides information about the system's state to the environment. This flow of information is what causes decoherence, the process by which the system collapses into a single,
definite classical state. It is a secret that,
once told to the world, is no longer a secret. The cerebellum, located at the back of the brain, coordinates voluntary movements. This densely folded structure, whose name means little brain, contains more neurons than the rest of the brain combined. While it doesn't initiate movement, it is absolutely crucial for its smooth, coordinated execution. It takes the rough motor commands from the cerebral cortex and refines them, adjusting timing and precision. It is what allows you to ride a bicycle, play a piano, or sign your name without conscious thought. It is the seat of your muscle memory, the master of practiced automatic skills. It is the part of your mind that knows how to move without thinking. The Higgs field gives fundamental particles their mass. Space-time is not empty. It is filled with an invisible energy field called the Higgs field. When the universe was very young and hot, all particles were massless and zipped around at the speed of light. As the universe cooled, the Higgs field turned on. Particles that interact strongly with this field experience a kind of drag, which we perceive as mass. Particles that interact weakly, like quarks, have a small mass. Particles that don't interact with it at all, like photons, remain massless. Mass is not an intrinsic property of a particle, but a measure of its interaction with this universal field. Massy is the resistance a particle feels as it moves through the substance of the cosmos. The feeling of free will may be a construct of the conscious mind after. The brain has already decided. Famous experiments in neuroscience have shown that brain activity associated with a decision can be detected up to several seconds before the person is consciously aware of having made the choice. This suggests that what we experience as a conscious decision might be a retrospective justification for an action that was initiated by unconscious neural processes. This doesn't necessarily mean free will is an illusion, but it does complicate our simple, intuitive understanding of how we make choices. Your conscious mind may be the last to know its own intentions. A photon travels across the galaxy for millions of years, but for the photon, no time passes at all. This is a direct consequence of Einstein's theory of special relativity. An object's experience of time is relative to its speed. As you approach the speed of light, time slows down. For a photon, which travels at the speed of light, time dilation is infinite. This means that from the photon's own reference frame, its journey is instantaneous. The moment it is emitted from a distant star and the moment it is absorbed by your eye are, for the photon, the same moment. It is a timeless traveler. It experiences a journey of 1,000,000 years as a single, indivisible instant. The boundary between the living and non-living is indistinct at the molecular level. We have a clear, intuitive sense of what is alive and what is not.
a rock is not alive, a bird is.
But as you zoom in, this distinction becomes blurry. A virus, for example, is a complex package of genetic material and protein that is inert, like a crystal, till it hijacks the machinery of a living cell. Prions are even simpler, just misfolded proteins that can cause other proteins to misfold. At this level, life becomes a matter of complex, self-replicating chemistry, a pattern of organization, rather than a fundamental substance. The way enzymes work so efficiently may depend on quantum tunneling. Enzymes are biological catalysts, proteins that speed up chemical reactions in the body by incredible amounts. They work by bringing molecules together in precisely the right orientation. However, some reactions happen even faster than classical models would predict. It's now believed that quantum tunneling plays a role. An electron or a proton, for instance, doesn't need to have enough energy to climb over the energy barrier of the reaction. It can simply tunnel through it, dramatically increasing the reaction speed. Life, at its most basic chemical level, leverages quantum weirdness. Biology cheats at the game of chemistry using the rules of quantum physics. Your pupils dilate not only in response to light, but also to emotional arousal. The size of your pupils is controlled by your autonomic nervous system, the same system that governs your heart rate and breathing. While they constrict in bright light and dilate in darkness, they are also a window into your mind. When you are looking at something you find interesting, beautiful, or emotionally engaging, your pupils will subtly dilate. This response is completely involuntary, a silent, bodily signal of your inner state of attention and arousal. Your eyes reveal your interest without a word being spoken. Quantum Darwinism is an idea that suggests stable reality emerges from the quantum world. This theory attempts to explain how the strange, probabilistic quantum world gives rise to the solid, objective, classical world we experience. It proposes that certain quantum states are more stable and robust than others. When a quantum system interacts with its environment, information about its state is copied over and over into the environment. Only the most stable, fittest states survive this process of information duplication. And it is these robust, redundantly recorded states that we perceive as objective reality. The classical world is the fossil record of the quantum realm. The brain contains its own lymphatic system to clear out waste products while you sleep. For a long time, it was believed the brain lacked a lymphatic system, the network that clears metabolic waste from the rest of the body. Recently, scientists discovered the glymphatic system, a unique plumbing network for the brain. It works primarily when you are asleep. During deep sleep, your brain cells actually shrink slightly, widening the channels between them and allowing cerebrospinal fluid to flush through and wash away the toxic protein byproducts that accumulate during the day. This is why a good night's sleep is so crucial for mental clarity. Sleep is the cleansing tide that washes the shores of the mind. String theory posits that all particles are just different vibrations of a tiny, fundamental string. This is one of the leading candidates for a theory of everything. It proposes that the fundamental constituents of reality are not point-like particles, but unimaginably small, one-dimensional vibrating strings of energy. Just as a violin string can vibrate at different frequencies to produce different musical notes, these fundamental strings can vibrate in different patterns. What we perceive as an electron is a string vibrating in one way. A photon is a string vibrating in another. All the particles and forces of the universe are just the different notes in a grand cosmic symphony. The universe is a song played on an orchestra of infinitesimal strings. The
amygdala acts as the brain's threat detection system.
This pair of small, almond-shaped structures, deep in the temporal lobes, is a key part of your limbic system. The amygdala is constantly scanning your sensory input for anything that might be dangerous or important for your survival. When it detects a potential threat, it can trigger a rapid, unconscious fear response, the fight or flight reaction, long before your conscious mind has had a chance to fully process what is happening. It is an ancient primal alarm system designed to keep you safe in a world of potential dangers. It is the vigilant watchtower in the fortress of your mind. A measurement in one part of an entangled system instantly affects the other.
regardless of distance.
This is the core of the spooky action at a distance that so bothered Einstein. If you have two entangled particles, one on Earth and one in the Andromeda Galaxy, and you measure the spin of the particle on Earth to be up, you know with absolute certainty that a measurement of the particle in Andromeda will yield a spin of down. This influence happens instantaneously, seemingly violating the cosmic speed limit of light. It doesn't allow for faster-than-light communication, but it reveals a deep, non-local connection woven into the fabric of reality. The universe has connections that are deeper than distance. Consciousness could be an emergent property, like wetness emerging from water molecules. A single molecule of H2O is not wet. Wetness is a property that emerges only when you have a large collection of these molecules interacting with each other. In the same way, a single neuron is not conscious. It is a biological machine that responds to electrochemical inputs. The prevailing view in neuroscience is that consciousness is an emergent property that arises from the incredibly complex interactions of billions of these neurons. It is a collective phenomenon, a property of the whole system that is not present in any of its individual parts. It is the whole becoming something more than the sum of its parts. The fabric of space-time is not smooth, but a roiling foam at the smallest scales. At our macroscopic level, space-time seems smooth and continuous, but at the unimaginably small scale known as the Planck length, it is thought that quantum effects would become dominant. At this level, space-time itself would be subject to the uncertainty principle, constantly fluctuating and bubbling. Tiny wormholes and fleeting universes might be popping in and out of existence. This quantum foam would be the fundamental graininess of reality, the chaotic, probabilistic substrate from which the smooth, classical world emerges. Reality's calm surface hides a turbulent, deep ocean. The brain uses about the same amount of energy during sleep as it does when awake. It may seem that sleep is a time of rest for the brain, but this is far from true. While some parts of the brain become less active, others, particularly those involved in memory consolidation and emotional processing, become even more active than during waking hours. The brain is hard at work during the night, filing away the day's experiences, clearing out waste products, and preparing itself for the next day. Sleep is not a state of inactivity, but a different state of activity, essential for mental and physical health. The mind's work continues long after the body is still. Wave-particle duality exists for all objects, not just subatomic particles. The principle that objects can behave as both waves and particles is a cornerstone of quantum mechanics, and it applies to everything, including you. However, an object's wavelength, known as its de Broglie wavelength, is inversely proportional to its momentum. For a tiny electron, this wavelength is significant enough to be observed in experiments. But for a macroscopic object like a baseball or a person, the wavelength is so infinitesimally small that its wave-like nature is completely undetectable.
You are a wave,
but a wave of such short length that you will always appear as a solid particle. You are a wave that thinks it is a stone. Mirror neurons fire both when you perform an action and when you see someone else perform it. Discovered in the brains of monkeys and later identified in humans, these remarkable cells seem to blur the line between self and other. A mirror neuron will fire when you reach for a cup of coffee, but it will also fire when you simply watch someone else reach for a cup of coffee. This neural mirroring is thought to be the basis for empathy, imitation, and our ability to understand the intentions and feelings of others. It is as if, at a cellular level, your brain simulates the experience of the people you observe. Empathy is the brain's internal echo of another's. Life. Quantum entanglement creates correlations that are stronger than any classical system could allow. The connections between entangled particles are not just simple correlations, like the glove-in-a-box analogy. The physicist John Bell devised a mathematical theorem that proved that the correlations predicted by quantum mechanics are fundamentally different and stronger than any that could be explained by some pre-existing hidden variable theory, experiments have repeatedly confirmed Bell's theorem, ruling out Einstein's preferred explanation and forcing us to accept the deeply strange, non-local nature of quantum reality. The universe's connections are woven with a logic stranger than our own. The neocortex, the wrinkled outer layer of the brain, is the seat of higher-order thought. This is the most recently evolved part of the human brain. Its characteristic folded and wrinkled appearance is nature's way of fitting a very large surface area into the compact space of the skull. This is where most of our complex cognitive functions take place: conscious thought, language, planning, reasoning, and sensory perception. The vast expansion of the neocortex during human evolution is what distinguishes us most from other animals, providing the neural hardware for culture, art, and science. It is the landscape upon which the story of humanity is written. Life is not a thing, but a process. Quantum decoherence is the process by which a system loses its quantum nature. This is the continuous, incredibly fast process through which the strange world of quantum possibilities transitions into the familiar, solid world of classical objects. A quantum system, like an electron in superposition, is constantly interacting with its environment, colliding with air molecules, absorbing stray photons. Each interaction leaks a little bit of information about the electron's state out into the wider world. This entanglement with the environment is what effectively destroys the superposition, forcing the particle into a single, definite state. It is the process of a possibility becoming a fact. The brain's language centers are typically located in the left hemisphere. For about 95% of right-handed people and about 70% of left-handed people, the crucial areas for language processing reside in the left side of the brain. Two key areas are Broca's area, which is involved in the production of speech, and Wernicke's area, which is involved in the comprehension of language. While the right hemisphere also plays a role, particularly in understanding the emotional tone and context of speech. This strong lateralization of language is one of the most well-known examples of brain specialization. The code of language is written predominantly on one side of the mind. It is mathematically possible for all the air molecules in a room to spontaneously move to one corner. According to the laws of statistical mechanics, the motion of individual air molecules is random. While it is overwhelmingly probable that they will remain evenly distributed throughout a room, there is an infinitesimally small, but non-zero probability that just by random chance, all of the trillions of molecules will happen to move into the same corner at the same time, leaving the rest of the room in a vacuum. The odds against this are so astronomically huge that it would likely never happen in the entire age of the universe. But it is not, strictly speaking, impossible. The universe allows for miracles. It just makes them incredibly unlikely. The human brain is the most complex object in the known universe. This is not hyperbole, but a statement based on the sheer number of its components and their intricate connectivity. With its 86 billion neurons and hundreds of trillions of synaptic connections, the combinatorial complexity of the brain's potential states exceeds the number of elementary particles in the universe. We have discovered distant galaxies and the fundamental particles of matter, but the 3-pound universe of tissue between our ears remains one of the greatest and most profound frontiers of scientific exploration. The map of the cosmos is less complex than the map of the mind that conceived it. The Wheeler-DeWitt equation attempts to describe the wave function of the entire universe. Just as the Schrödinger equation describes the wave function of a particle, this equation, a central idea in quantum gravity, attempts to do the same for the entire cosmos. It is a highly speculative and controversial equation, but it has a fascinating feature. It contains no time variable. This suggests that at the most fundamental quantum level of reality, time does not exist. Time, as we perceive it, might be an emergent property of a timeless, static quantum reality. The universe, in this view, just is a single, unchanging block. At the deepest level, Everything that will ever happen has already happened. The brain can recognize a familiar face in less than 1/10 of a second. Your ability to recognize faces is a remarkable feat of neural computation. Your brain has a specialized area, the fusiform face area, that is dedicated to this task. It can process the complex pattern of a face, the spacing of the eyes, the shape of the nose, and match it to a memory with incredible speed and accuracy, even if the face has changed with age or is seen from a different angle. This specialized, high-speed circuit highlights how important facial
recognition has been for us as a social species. Your mind has a dedicated library just for
faces. The concept of locality seems to be violated by quantum mechanics. Locality is the common sense idea that an object can only be influenced by its immediate surroundings. For something to affect something else, a force or signal must travel through the space between them. Quantum entanglement, however, seems to defy this. The instantaneous connection between two entangled particles, no matter how far apart, suggests a non-local aspect to reality. It's as if, at some deeper level, the two particles are not separate objects at all, and the space between them does not truly exist. The universe is more connected than it is distant. Your DNA is constantly being damaged and repaired by cellular machines. Your genetic code is under constant assault from both internal and external sources, such as metabolic byproducts and environmental radiation. This can cause thousands of instances of DNA damage in every single cell, every single day. To counteract this, your cells have a sophisticated army of repair proteins that constantly patrol the DNA strands, identifying errors, cutting out damaged sections, and resynthesizing the correct sequence. This tireless process of surveillance and repair is essential for maintaining the integrity of your genetic blueprint and preventing disease. Life is a constant process of mending its own foundations. Some physicists believe time itself might be an emergent quantum phenomenon. This idea suggests that time is not a fundamental aspect of reality. Instead, it might emerge from quantum entanglement. In this model, a static, timeless universe can be divided into subsystems. When these subsystems become entangled with each other, an observer within one of the subsystems would perceive the state of the other as changing. This perceived change, this evolution of entanglement, is what we experience as the flow of time. Time, then, is a relationship between parts of the universe, not a feature of the universe as a whole. Time is the name we give to the changing relationship between things. The thalamus acts as a relay station for nearly all incoming sensory information. Located deep in the center of the brain, the thalamus is a critical hub. With the exception of the sense of smell, all sensory signals from your eyes, ears, skin, and tongue pass through the thalamus before being routed to the appropriate areas of the cerebral cortex for higher-level processing. But it is not just a passive switchboard. The thalamus also plays a role in regulating sleep, wakefulness, and alertness, deciding which sensory information is important enough to be sent on to the conscious mind. It is the gatekeeper at the door of your conscious perception. Every time you recall a memory, you are subtly changing it. The act of remembering is not like playing back a recording. It is an act of reconstruction. When you access a memory, you are reactivating a neural pattern, and this makes the memory temporarily unstable and malleable. It can then be influenced by your current mood, beliefs, and new information before it is reconsolidated or stored again. This is why memories can shift and change over time. Each recall is not just a viewing, but an editing session. The past is not a fixed landscape, but a painting that you touch up with every viewing. The idea of a quantum soul posits a non-material consciousness that interacts with the brain. This is a more philosophical interpretation that attempts to bridge the gap between science and spirituality. Drawing on the observer effect in quantum mechanics, some have proposed that consciousness is a fundamental, non-physical entity that can influence the probabilistic nature of the quantum world. In this view, the soul or consciousness can can affect the brain by influencing the collapse of the wave function at the synaptic level, allowing a non-material mind to interact with the physical brain without violating the conservation of energy. It is the idea of a ghost in the quantum machine. M theory in physics suggests the existence of 11 dimensions. String theory, our leading candidate for a unified theory, actually exists in several different versions. In the 1990s, it was discovered that these different versions could be seen as different aspects of a single underlying theory, which was named M theory. This deeper theory posits a universe with 11 dimensions, 10 of space and 1 of time. We only perceive 3 spatial dimensions because the other 7 are thought to be curled up or compactified into an incredibly tiny size, far too small for us to ever directly experience. There may be hidden universes curled up within the fabric of our own. Your brain uses over 100 different types of neurotransmitters. While a few, like serotonin and dopamine, are well known, they are just a tiny fraction of the chemical messengers at the brain's disposal. Each neurotransmitter has a different shape and binds to different types of receptors, allowing for an incredible diversity and subtlety of signaling. Some are excitatory, encouraging neurons to fire, while others are inhibitory. The complex interplay of this vast chemical vocabulary is what allows for the rich spectrum of thought, emotion, and behavior. The brain is a master of chemical conversation. It is an alphabet with over 100 different letters. The Copenhagen interpretation of quantum mechanics gives a special role to the observer. This is the oldest and most standard interpretation of quantum mechanics. It states that a quantum system is described by a wave function that represents all its possibilities. This wave function evolves predictably until a measurement is made by a classical observer. At that point, the wave function inexplicably collapses into one of the possible states. This interpretation draws a sharp and still mysterious line between the quantum world and the classical world of the observer, without fully explaining how or why the act of
Measurement is so special, it suggests that our world is the
one that makes the quantum world decide. Your sense of smell is deeply intertwined with the parts of your brain that process emotion. The olfactory bulb, which processes signals from your nose, has direct connections to the amygdala, the emotion center, and the hippocampus, the memory center. This unique and direct neural wiring is why smells can trigger such powerful and immediate emotional memories, more so than any other sense. The scent of baking cookies might not just remind you of your grandmother's kitchen, it can instantaneously transport you back there, evoking the full feeling of warmth and safety. Smell is the sense that speaks most directly to the heart. A particle's wave function can interfere with itself, creating patterns of probability. The wave-like nature of a particle is not just an analogy. In the double-slit experiment, the particle's wave of probability passes through both slits. The wave from the left slit then interferes with the wave from the right slit. In some places, the crests of the waves meet and reinforce each other, creating a high probability of finding the particle there. In other places, a crest meets a trough and they cancel each other out, creating a 0 probability of finding the particle there. This self-interference is what creates the characteristic striped pattern. A single particle can be in a silent argument with itself. The blood-brain barrier is a highly selective gatekeeper protecting your central nervous system. Your brain is protected by a special lining of cells in its capillaries that is much less permeable than in the rest of the body. This blood-brain barrier acts like a strict border control, letting essential molecules like oxygen and glucose pass through while blocking potentially harmful toxins, pathogens, and most medications from entering the brain's delicate environment. While crucial for protection, this barrier also presents a major challenge for treating brain diseases,
as it can be very difficult to design drugs that can get past its
defenses. It is a fortress wall built around the city of the mind. The delayed choice quantum eraser experiment suggests a measurement today can affect the past. This is a more complex version of the double-slit experiment that produces truly baffling results. In it, information that reveals which slit a particle went through can be either kept or erased after the particle has already hit the detector screen. If the which path information is kept, no interference pattern appears, but if it is erased, the interference pattern retroactively appears. It is as if the choice to erase the information in the future determines whether the particle behaved like a wave in the past. The present holds the power to change the story of the past. Dopamine is involved in motivation, reward, and the anticipation of pleasure. Often called the pleasure chemical, dopamine's role is more subtle. It is less about the experience of pleasure itself and more about the motivation and desire to seek it out. Your brain releases dopamine in response to cues that predict a rewarding experience, like the sight of delicious food or the sound of a loved one's voice. This surge of dopamine is what creates the feeling of wanting and drives you to pursue goals. It is the engine of your ambition and your desires. It is the chemical of what if and let's find out. The universe had no up or down until gravity created the first structures. In the very early universe, matter was distributed almost perfectly evenly. There was no direction, no structure, just a uniform expanding sea of particles. It was only when gravity began to amplify the tiny, random density fluctuations that the first structures began to form. Matter clumped together to create the first stars and galaxies, and in doing so created the concepts of here and there, of centers of mass and the directions of gravitational pull. Structure itself is a product of gravity's patient work. Gravity is the force that gave the universe a geography. The binding problem in neuroscience asks how the brain combines separate sensations into one unified experience. Your brain processes different aspects of an object in different areas. The color is processed in one place, the shape in another, the motion in another, and the sound in yet another. The binding problem is the deep question of how all these separate streams of processing are integrated or bound together into the single, coherent, unified object you perceive in your consciousness. We don't yet know the mechanism, but synchronized neural firing, or brainwaves, is a leading candidate. It is the mystery of how the brain turns a list of features into a single face. Retrocausality is the speculative idea that effects can precede their causes. Inspired by some of the bizarre results of quantum experiments, the concept of retrocausality takes things a step further than just future actions influencing the past. It suggests that causation can literally run backwards in time. In this view, the state of a particle now might be influenced not only by its past interactions, but also by the measurements that will be performed on it in the future. It is a radical idea that would require a complete overhaul of our understanding of time and causality, but one that some physicists are seriously considering. It is the idea that tomorrow can whisper instructions to today. Long-term potentiation is the process that strengthens synapses, forming the basis of memory. When two neurons fire at the same time repeatedly, the connection between them gets stronger. This process is called long-term potentiation, or LTP. It involves physical and chemical changes at the synapse that make the receiving neuron more responsive to the signals from the sending neuron. This strengthening of connections is believed to be the primary cellular mechanism behind learning and memory. When you learn a fact or a skill, you are inducing LTP in specific neural circuits, making that pattern of firing easier to reactivate in the future. It is the process of carving a memory into the pathways of the brain. The quantum Zeno effect is a phenomenon where an unstable particle, if watched continuously, will never decay. An unstable radioactive atom will eventually decay, but it is impossible to predict the exact moment. The process is governed by probability. However, the quantum Zeno effect, named after the Greek philosopher Zeno and his paradoxes of motion, shows that if you continuously measure the atom to see if it has decayed, The act of measurement itself repeatedly resets the decay clock, effectively freezing the atom in its undecayed state. The old saying, "a watched pot never boils," has a surprising and literal truth in the quantum world. Observation can be a cage that holds reality in place. The brain continues to develop and change well into your 20s. For a long time, it was thought that brain development was largely complete by adolescence. We now know that the brain, particularly the prefrontal cortex responsible for judgment and decision-making, continues to mature and rewire itself throughout the late teens and into the mid-20s. The process of myelination, where nerve fibers are coated with a fatty sheath to speed up signal transmission, is still ongoing during this period. This extended period of development is what allows for the complex social and cognitive learning that marks the transition into adulthood. The mind takes a quarter of a century to fully blossom. The spin of a particle can be up, down, or a superposition of both. This property, which we call spin, is one of the fundamental quantum numbers of a particle. For a particle like an electron, its spin can be measured to be in one of two states, which we label up and down for convenience. But before it is measured, it exists in a combination, a superposition of both states simultaneously. The mathematics describing this are precise, allowing for any weighted combination of the two possibilities, like a point on the surface of a sphere. This sphere of possibilities is known as the Bloch sphere. It is a compass needle that points north and south at the same time. Serotonin plays a crucial role in mood, appetite, and sleep. This widely known neurotransmitter is a master regulator in the brain, influencing a vast array of functions. While it is most famous for its connection to feelings of well-being and happiness, serotonin is also involved in managing the sleep-wake cycle, controlling appetite, and regulating social behavior. Interestingly, the vast majority of the body's serotonin, over 90%, is actually found not in the brain, but in the gut, where it plays a key role in regulating the digestive system. It is a chemical that links the contentment of the mind to the calmness of the body, the many world. Interpretation suggests all possible outcomes of a quantum measurement actually occur. To solve the mystery of why we only see one outcome when many are possible, this interpretation proposes a radical solution. Every possible outcome happens. At each quantum event, the entire universe splits into multiple copies, one for each possible result. In one universe, the particle went left. In another, it went right. There is no collapse of the wave function, only a constant, exponential branching of reality into a vast multiverse of parallel, non-communicating timelines. Every choice you've ever made has been realized in some other world. Your brain is composed of roughly 75% water. This high water content is vital for every aspect of brain function. Water acts as a solvent for the ions needed for electrical signals. It helps transport nutrients and remove waste, and it regulates temperature. The brain's consistency is often compared to that of soft tofu or gelatin, a delicate, semi-solid structure that is highly vulnerable to dehydration. Even a small drop in hydration can lead to a noticeable decline in cognitive functions like concentration, memory, and reaction time. The river of thought flows through a landscape made of water. Quantum coherence is a delicate state easily disturbed by heat or vibration. Maintaining the state of superposition necessary for quantum effects is the single biggest challenge in building a quantum computer. Any interaction with the outside world, what physicists call noise, can cause the system to decohere and lose its quantum properties. This is why quantum computers must be kept in highly isolated environments, shielded from radiation and cooled to temperatures colder than deep space, just fractions of a degree above absolute zero, to minimize thermal vibrations and keep the delicate quantum symphony playing. It is a state of being as fragile as a soap bubble. The brain is remarkably resilient and can often rewire itself to compensate for damage. Through the power of neuroplasticity, the brain can show an amazing ability to recover from injury. If one part of the brain is damaged, its functions can sometimes be taken over by other healthy areas. For example, in stroke patients who have lost the ability to speak, dedicated therapy can sometimes encourage the brain to remap language functions to undamaged regions. The brain is not a collection of rigid, single-purpose modules, but a dynamic and adaptable network that can
reconfigure itself in the face of
adversity. It is a city that can reroute its traffic around a damaged bridge. A positron is the antimatter counterpart of the electron. Discovered in 1932, the positron has the same mass as an electron, but an equal and opposite positive charge. It was the first piece of antimatter to be discovered, confirming a theoretical prediction by Paul Dirac. Positrons are created in certain types of radioactive decay and in high-energy particle collisions. When a positron collides with an electron, they annihilate each other, and their entire mass is converted into two gamma-ray photons, a perfect and complete transformation of matter into energy. It is the electron's perfect, fleeting shadow. The process of thinking is a form of controlled chaos within the brain's network. The patterns of neural firing in the brain often exist in a state known as the edge of chaos. This is a delicate balance point between too much order, where the brain would get stuck in rigid, repetitive patterns, and too much randomness, where no stable thoughts could form. By operating in this critical state, the brain remains both stable enough to store memories and flexible enough to generate novel ideas and adapt to new situations. It is a system that thrives on a precise mixture of order and surprise. Creativity is born in the borderlands between pattern and randomness. The Planck length is the smallest possible distance in the universe. At about 1.61035 meters, this is the scale at which the classical ideas of gravity and space-time cease to make sense. It is the fundamental unit of length in the universe, the pixel size of reality. It is so unimaginably small that if you were to scale up an atom to the size of the known universe, the Planck length would be the size of an average tree. At this scale, space-time itself is thought to dissolve into the chaotic quantum foam. It is the final, indivisible grain of space. The default mode network is where your mind goes when it reflects on the past or imagines the future. This network, most active when you are at rest, seems to be dedicated to the construction of your self-narrative. It is what allows you to mentally travel in time, revisiting past events or simulating future possibilities. This ability to detach from the immediate present and contemplate the non-present is a hallmark of human cognition. The default mode network is the loom upon which the brain weaves the story of your life, connecting your past, present, and future into a coherent whole. It is the home of your inner storyteller. Quantum field theory combines quantum mechanics with special relativity. It is the theoretical framework that underlies the standard model of particle physics. It successfully merges the principles of quantum mechanics, which governs the small, with Einstein's theory of special relativity, which governs the fast. In QFT, the fundamental entities are not particles, but fields that permeate all of space-time. Particles are just the quantized excitations of these fields. It provides a powerful and elegant language for describing how particles are created, destroyed, and interact with one another. It is the mathematical language that describes the dance of creation and annihilation. The brain's electrical signals travel at speeds of up to 268 miles per hour. The speed of an action potential, the electrical impulse in a neuron, depends on the axon's diameter and whether it is coated in a fatty sheath called myelin. The thickest, most heavily myelinated neurons, which typically carry urgent sensory or motor information, can transmit signals at these incredible speeds. This high-speed communication network allows your brain to receive information, process it, and react to the world in fractions of a second. A thought can travel faster than a race car. The arrow of time is linked to the universe's increasing entropy, or disorder. The second law of thermodynamics states that the total entropy or disorder of a closed system will always increase over time. An egg can scramble, but a scrambled egg cannot unscramble itself. A cup of coffee cools down, but a cool cup of coffee doesn't spontaneously heat up. The reason we experience time as moving forward is because we live in a universe that started in a very low entropy, highly ordered state at the Big Bang and has been moving towards a state of greater disorder ever since. The arrow of time is the arrow of increasing chaos. Time's passage is the universe slowly unraveling. Neurogenesis is the process by which new neurons are formed in the brain. For decades, it was dogma in neuroscience that we are born with all the neurons we will ever have. We now know this is not true. In at least 2 areas of the adult brain, the olfactory bulb and, crucially, the hippocampus, new neurons are generated throughout our lives. This process of adult neurogenesis is thought to be important for learning, memory, and mood regulation. It is a remarkable sign of the brain's ongoing capacity for change and renewal. The mind is a garden where new seeds can still sprout. The measurement problem is the unresolved question of how wave function collapse occurs. This is perhaps the biggest and most fundamental mystery in quantum mechanics. The theory gives us 2 different rules for how a quantum system evolves: the smooth, predictable evolution of the wave function and the sudden, random collapse that happens when a measurement is made. The measurement problem is the question of what constitutes a measurement. Is it an interaction with a large object? Does it require a conscious observer? There is no consensus, and this deep conceptual puzzle is what gives rise to the various interpretations of quantum mechanics. It is the seam that shows between the quantum world and our own, your perception of color is a subjective experience created by your brain's interpretation of light frequencies. The physical world contains no color. It contains electromagnetic radiation of different wavelengths. When light of a certain wavelength enters your eye, it stimulates specific cone cells in your retina, which send a particular signal to your brain. Your brain then interprets that signal and creates the subjective internal experience of red or blue. The qualia of color, the actual feeling of seeing it, exists only in your mind. Color is a song that the brain sings to itself. The weak nuclear force is responsible for radioactive decay. One of the 4 fundamental forces of nature, the weak force, operates at the subatomic level. It is much weaker than the strong nuclear force that holds the nucleus together, but it is unique in its ability to change one type of subatomic particle into another. For example, the weak force can change a neutron into a proton, an electron, and an antineutrino. This process, known as beta decay, is a common form of radioactivity and is also the fundamental process that powers the sun by allowing hydrogen to fuse into helium. It is the force of transformation. The brain's structure is a fractal, with similar patterns repeating at different scales. A fractal is a mathematical object that exhibits self-similarity at different levels of magnification. The brain shows many fractal-like properties. The branching pattern of a single neuron's dendrites looks similar to the pattern of larger neural networks. The wrinkled folding of the cerebral cortex follows fractal geometry, allowing for a massive surface area to be packed into a small volume. This suggests that the brain uses a few simple, repeated developmental rules to generate its immense complexity. It is a simple pattern, repeated into infinity. The law of conservation of energy states that energy can neither be created nor destroyed. This is one of the most fundamental and well-tested principles in all of science. Energy can change forms from chemical energy in food to mechanical energy in your muscles, or from electrical energy to light and heat in a bulb, but the total amount of energy in a closed system always remains constant. It is a deep and beautiful symmetry of the universe,
A statement that beneath all the change and transformation we see,
something essential is always conserved. The universe's total fire never grows or shrinks. It only changes its shape. Your attention works like a spotlight. highlighting certain information for conscious processing. At any given moment, your brain is receiving a torrent of sensory information. Your attention is the cognitive mechanism that allows you to select a small fraction of this information for deeper processing while filtering out the rest. This attentional spotlight can be directed voluntarily when you decide to focus on reading a book, or it can be captured involuntarily by a sudden, loud noise. This selective process is essential for navigating a complex world without being completely overwhelmed. Attention is the gatekeeper of consciousness. A black hole is a region of space-time where gravity is so strong that nothing can escape. When a very massive star exhausts its nuclear fuel, it can collapse under its own gravity. If the core is massive enough, it will collapse indefinitely, crushing matter into a point of infinite density called a singularity. This singularity warps space-time around it so severely that it creates a boundary called the event horizon. Anything that crosses this boundary, a planet, a star, even light itself, can never escape the black hole's gravitational pull. It is a one-way door out of the known universe. It is a place where gravity has won its final victory. Endorphins are the body's natural pain relievers. These neurotransmitters, whose name is a contraction of endogenous morphine, are produced by the central nervous system and pituitary gland. They bind to the same opioid receptors in the brain that are targeted by pain-relieving drugs. Your body releases endorphins in response to pain or stress, creating a sense of analgesia and well-being. They are responsible for the runner's high and our ability to push through physical hardship. They are the body's own gentle built-in comfort. They are the body's whisper that says, "This too shall pass." The principle of complementarity states that an object's quantum properties cannot be viewed simultaneously. Articulated by Niels Bohr, this principle is a cornerstone of the Copenhagen interpretation. It states that certain properties of a quantum object are complementary pairs, like its wave-like and particle-like aspects. You can design an experiment to measure one aspect, but in doing so, you preclude the possibility of measuring the other at the same time. The full reality of a quantum object can only be understood by considering all of its complementary and mutually exclusive properties. You cannot see both sides of a quantum coin at the same time. The brain can make decisions before the conscious mind is aware of them. The neuroscientific experiments by Benjamin Libet in the 1980s were landmark, if controversial, studies on free will. They showed that a buildup of electrical potential in the brain, called the readiness potential, could be detected for a simple motor decision, like when to flick one's wrist, up to half a second before the subject reported the conscious intention to act. This has been interpreted by some to mean that our conscious decision is more of an after-the-fact awareness of a decision already made by unconscious processes. Consciousness may be the passenger, not the driver. Time slows down in a strong gravitational field. According to Einstein's theory of general relativity, gravity is the curvature of space-time caused by mass and energy. One of the consequences of this curvature is that time runs more slowly closer to a massive object. This effect, known as gravitational time dilation, is real and measurable. GPS satellites, which are in a weaker gravitational field than we are on the surface, must have their clocks constantly adjusted to account for the fact that time is running slightly faster for them. If they didn't, the entire GPS system would fail within minutes. Gravity is a force that stretches not just space, but time itself. The cerebral cortex contains billions of neurons arranged in distinct layers. The wrinkled outer surface of your brain, the neocortex, has a highly organized structure. Its neurons are arranged in 6 distinct horizontal layers, stacked on top of each other like the layers of a cake. These layers are interconnected in complex vertical columns. It is thought that these cortical columns are the basic functional units of the cortex, each one a mini processor that handles a specific piece of information. The immense computational power of the cortex arises from the parallel processing of billions of these intricate microcircuits. The architecture of thought is a 6-story building, repeated billions of times. Quantum logic is a set of rules for reasoning about propositions that take quantum theory into account. Classical logic is based on our everyday experience. A statement is either true or false. But in the quantum world, a particle can be in a superposition of states. A proposition like the electron's spin is up is not necessarily true or false before a measurement. Quantum logic is a mathematical framework that attempts to create a system of reasoning that can handle these kinds of indeterminate statements. In quantum logic, some of the fundamental rules of classical logic, like the distributive law, no longer hold true. It is a way of thinking built for a world of maybes. The brain uses context and past experience to fill in missing information from your senses. Your perception is not just a raw feed of sensory data. It is an interpretation heavily influenced by your expectations. This is why you can read a sentence with misspelled words without much difficulty. Your brain expects certain patterns and automatically corrects the errors. It is also why optical illusions work. They exploit the brain's built-in assumptions about the world, like how light and shadow work, to create a perception that doesn't match reality. Your brain is a storyteller, and it will always try to make the incoming data fit into a coherent narrative. You see what your brain expects you to see. The strong nuclear force binds protons and neutrons together in an atom's nucleus. This is the most powerful of the 4 fundamental forces, but it only operates over incredibly short distances within the confines of the atomic nucleus. Protons are all positively charged and should repel each other with immense force. The strong force is what overcomes this electromagnetic repulsion, binding the protons and neutrons together to form a stable nucleus. It is the glue that holds the building blocks of matter together, a force of incredible strength that keeps the world from flying apart. It is the universe's most powerful and shortest embrace. The experience of awe can have measurable positive effects on the brain and body. Awe is the emotion we feel in the presence of something vast and overwhelming that challenges our understanding of the world, like looking up at a starry night sky or gazing into the Grand Canyon. Studies have shown that experiencing awe can reduce levels of inflammatory cytokines in the body, promote feelings of generosity and connectedness, and lead to a sense of time affluence, the feeling that you have more time available. It is an emotion that shifts our perspective from our small selves to the larger world around us. A Bose-Einstein condensate is a state of matter where separate atoms behave as a single quantum entity. When a gas of certain types of atoms is cooled to temperatures just a fraction of a degree above absolute zero, the atoms lose their individual identities and begin to act in unison. Their wave functions overlap to such an extent that the entire cloud of thousands or millions of atoms is described by a single wave function. They become, in effect, a single superatom. This strange and delicate state of matter, first predicted by Einstein and Bose in the 1920s, is a macroscopic display of quantum behavior. It is matter that has forgotten how to be separate. The basal ganglia are a group of structures involved in motor control and procedural learning. Located deep within the cerebral hemispheres, the basal ganglia are crucial for initiating and controlling voluntary movements. They are also essential for forming habits and learning procedures, the kind of how-to knowledge that becomes automatic with practice, like tying your shoes or driving a car. While the cerebellum refines the movements, the basal ganglia are involved in the selection and sequencing of those movements, helping you transition smoothly from one action to the next. They are the architects of your habits. Dark matter is a mysterious substance that does not interact with light but exerts gravitational force. The stars in galaxies are spinning so fast that, based on the visible matter we can see, they should fly apart. The fact that they don't tells us there must be some extra invisible mass providing the gravitational glue to hold them together.
This is dark matter.
We don't know what it is, but we know it's there because we can see its gravitational effects on the stars and on the path of light through the universe. It is a vast, invisible scaffolding upon which the luminous structures of the cosmos are built. The universe we see is just the light decorating an invisible structure. The act of sleeping helps consolidate memories, transferring them to long-term storage. During the day, your experiences are encoded as fragile short-term memories, primarily in the hippocampus. During deep, slow-wave sleep, the brain seems to replay these experiences. This neural replay, a kind of high-speed dialogue between the hippocampus and the cortex, is thought to be the process by which these memories are strengthened and integrated into the long-term knowledge network of the cortex. A good night's sleep is not just for resting the body, but for cementing the story of the previous day into the mind. Sleep is the librarian of the mind, working the night shift to file away the day's books. A superfluid is a liquid with zero viscosity that can flow without any loss of kinetic energy. When liquid helium is cooled to just a couple of degrees above absolute zero, it transforms into a superfluid. This strange quantum liquid can flow up the walls of its container and out, seemingly defying gravity. It can drip through cracks so small that even gas atoms cannot pass through them. Because it has no viscosity, a swirl created in a cup of superfluid helium will continue to spin, in theory, forever without slowing down. It is a liquid moving with a perfect, frictionless grace. It is a liquid that has learned the secret of perpetual motion. The brain's response to music involves multiple regions, including those for memory, emotion, and movement. Listening to music is a full brain workout. The auditory cortex processes the pitch and rhythm. The limbic system, including the amygdala and hippocampus, generates the emotional response and triggers associated memories. The motor cortex is also often engaged, which is why you might find yourself tapping your foot to a beat without even thinking about it. Music is not just heard. It is a holistic experience that engages the brain's most primitive and most evolved structures in a complex and harmonious dance. Music is a language that the entire brain understands. Schrödinger's cat thought experiment highlights the paradoxical nature of quantum superposition. Erwin Schrödinger devised this famous paradox to illustrate what he saw as the absurdity of the Copenhagen interpretation when applied to the macroscopic world. He imagined a cat in a sealed box with a radioactive atom that has a 50-50 chance of decaying in an hour. If it decays, it triggers a mechanism that kills the cat. According to quantum mechanics, until the box is opened and an observation is made, the atom is in a superposition of both decayed and not decayed. This would imply the cat is simultaneously both alive and dead until observed. It is a question that places life itself in a state of quantum suspense. Oxytocin is often called the bonding hormone for its role in social attachment. This neurotransmitter and hormone is released in the brain during social contact, such as hugging, and plays a crucial role in forming social bonds, trust, and empathy. It is central to the bond between a mother and a child, and it promotes feelings of generosity and group cohesion. While its effects are complex, oxytocin is a key part of the brain's chemical toolkit for navigating the social world, encouraging us to connect with and care for one another. It is the chemical signature of connection. The universe appears to be flat on a large scale. The geometry of space-time can take one of three forms. It can be curved positively like a sphere, negatively like a saddle, or it can be flat. Our best measurements of the cosmic microwave background radiation indicate that the universe is, with a very small margin of error, perfectly flat. This is a surprising result, as any deviation from flatness in the early universe would have been magnified enormously over cosmic time. This flatness problem is one of the key observations that the theory of cosmic inflation was developed to explained the canvas of the cosmos has no discernible curve. The concept of mind does not have a precise, universally agreed upon scientific definition. While we can study the brain and behavior, the mind, the realm of subjective experience, thoughts, feelings, and consciousness, remains elusive to formal definition. It is the so-called hard problem of consciousness. Why and how does the objective, physical processing of the brain give rise to the subjective, qualitative experience of being? We can map the neural correlates of consciousness, but the bridge between the physical and the mental remains the most profound gap in our scientific
understanding. The mind is the one thing we can
never observe from the outside. Quantum-y. Teleportation transfers information, not matter, from one location to another. This is not the beaming up of science fiction. It is not possible to teleport a physical object. Instead, quantum teleportation uses the principles of entanglement to transmit the complete information about a quantum state from one location to another. The process involves scanning the original particle, which destroys its state, and sending classical information to the receiving location, where that information is used to perfectly reconstruct the original state in another particle. It is a way of sending a perfect blueprint, not the building itself. Your circadian rhythm is an internal 24-hour clock that regulates your sleep-wake cycle. Deep within your brain, in the hypothalamus, is a tiny cluster of nerve cells called the suprachiasmatic nucleus. This is your body's master clock. It generates a natural, near 24-hour rhythm that governs your cycles of sleepiness and alertness, hormone release, and body temperature. This internal clock is synchronized with the external world primarily by light, which is why exposure to light in the morning and darkness at night is so crucial for maintaining a healthy sleep pattern. You have a clock made of cells that is wound by the rising of the sun. The universe's fundamental constants seem finely tuned to allow for the existence of conscious life. The values of constants like the strength of gravity, the mass of the electron, and the dark energy density appear to be set within an extraordinarily narrow range that is hospitable to life. If any of these values were even slightly different, the universe might have contained no stars, no planets, or no complex chemistry. This anthropic principle is either a sign of an incredible cosmic coincidence, evidence for a multiverse where all possible values exist, or a hint at some deeper, undiscovered principle governing the cosmos. The laws of physics seem to have been written with an audience in mind. The hippocampus is named after the Greek word for seahorse because of its shape. This vital brain structure, so crucial for memory and navigation, was given its name by an early anatomist who noted its curved, elegant shape in cross-section, which he thought resembled the graceful form of a seahorse. It is a small touch of poetry in the language of science, a name that links the seat of our most personal memories to a gentle creature of the sea. The chamber of memory is named for a creature of the deep. The collapse of the wave function may not be a physical event, but simply an update of an observer's knowledge. This is the central idea of interpretations like quantum Bayesianism or cubism. In this view, the wave function does not represent the objective state of a physical system. Instead, it represents an observer's subjective beliefs or knowledge about that system. The collapse of the wave function is not a physical process happening out in the world. It is simply the moment an observer gains new information from a measurement and updates their knowledge, their probability assignments, accordingly. The world doesn't change,
only our knowledge of it does.
Or is the feeling of the self becoming smaller and the world becoming larger. A Bose-Einstein condensate is a state of matter where separate atoms behave as a single quantum entity. When a gas of certain types of atoms is cooled to temperatures just a fraction of a degree above absolute zero, the atoms lose their individual identities and begin to act in unison. Their wave functions overlap to such an extent that the entire cloud of thousands or millions of atoms is described by a single wave function. They become, in effect, a single superatom. This strange and delicate state of matter, first predicted by Einstein and Bose in the 1920s, is a macroscopic display of quantum behavior. It is matter that has forgotten how to be separate. The basal ganglia are a group of structures involved in motor control and procedural learning. Located deep within the cerebral hemispheres, the basal ganglia are crucial for initiating and controlling voluntary movements. They are also essential for forming habits and learning procedures, the kind of how-to knowledge that becomes automatic with practice, like tying your shoes or driving a car. While the cerebellum refines the movements, the basal ganglia are involved in the selection and sequencing of those movements, helping you transition smoothly from one action to the next. They are the architects of your habits. Dark matter is a mysterious substance that does not interact with light but exerts gravitational force. The stars in galaxies are spinning so fast that, based on the visible matter we can see, they should fly apart. The fact that they don't tells us there must be some extra invisible mass providing the gravitational glue to hold them together. This is dark matter. We don't know what it is, but we know it's there because we can see its gravitational effects on the stars and on the path of light through the universe. It is a vast, invisible scaffolding upon which the luminous structures of the cosmos are built. The universe we see is just the light decorating an invisible structure. The act of sleeping helps consolidate memories, transferring them to long-term storage. During the day, your experiences are encoded as fragile, short-term memories, primarily in the hippocampus. During deep, slow-wave sleep, the brain seems to replay these experiences. This neural replay, a kind of high-speed dialogue between the hippocampus and the cortex, is thought to be the process by which these memories are strengthened and integrated into the long-term knowledge network of the cortex. A good night's sleep is not just for resting the body, but for cementing the story of the previous day into the mind. Sleep is the librarian of the mind, working the night shift to file away the day's books. A superfluid is a liquid with zero viscosity that can flow without any loss of kinetic energy. When liquid helium is cooled to just a couple of degrees above absolute zero, it transforms into a superfluid. This strange quantum liquid can flow up the walls of its container and out, seemingly defying gravity. It can drip through cracks so small that even gas atoms cannot pass through them. Because it has no viscosity, a swirl created in a cup of superfluid helium will continue to spin, in theory, forever without slowing down. It is a liquid moving with a perfect, frictionless grace. It is a liquid that has learned the secret of perpetual motion. The brain's response to music involves multiple regions, including those for memory, emotion, and movement. Listening to music is a full brain workout. The auditory cortex processes the pitch and rhythm. The limbic system, including the amygdala and hippocampus, generates the emotional response and triggers associated memories. The motor cortex is also often engaged, which is why you might find yourself tapping your foot to a beat without even thinking about it. Music is not just heard. It is a holistic experience that engages the brain's most primitive and most evolved structures in a complex and harmonious dance. Music is a language that the entire brain understands. The Schrödinger's cat thought experiment highlights the paradoxical nature of quantum superposition. Erwin Schrödinger devised this famous paradox to illustrate what he saw as the absurdity of the Copenhagen interpretation when applied to the macroscopic world. He imagined a cat in a sealed box with a radioactive atom that has a 50-50 chance of decaying in an hour. If it decays, it triggers a mechanism that kills the cat. According to quantum mechanics, until the box is opened and an observation is made, the atom is in a superposition of both decayed and not decayed. This would imply the cat is simultaneously both alive and dead until observed. It is a question that places life itself In a state of quantum suspense, oxytocin is often called the bonding hormone for its role in social attachment. This neurotransmitter and hormone is released in the brain during social contact, such as hugging, and plays a crucial role in forming social bonds, trust, and empathy. It is central to the bond between a mother and a child, and it promotes feelings of generosity and group cohesion. While its effects are complex, oxytocin is a key part of the brain's chemical toolkit for navigating the social world, encouraging us to connect with and care for one another. It is the chemical signature of connection. The universe appears to be flat on a large scale. The geometry of space-time can take one of three forms. It can be curved positively like a sphere, negatively like a saddle, or it can be flat. Our best measurements of the cosmic microwave background radiation indicate that the universe is, with a very small margin of error, perfectly flat. This is a surprising result, as any deviation from flatness in the early universe would have been magnified enormously over cosmic time. This flatness problem is one of the key observations that the theory of cosmic inflation was developed to explain. The canvas of the cosmos has no discernible curve. The concept of mind does not have a precise, universally agreed upon scientific definition. While we can study the brain and behavior, the mind, the realm of subjective experience, thoughts, feelings, and consciousness, remains elusive to formal definition. It is the so-called hard problem of consciousness. Why and how does the objective, physical processing of the brain give rise to the subjective, qualitative experience of being? We can map the neural correlates of consciousness, but the bridge between the physical and the mental remains the most profound gap in our scientific.
Understanding the mind is the one thing we can
Never observe from the outside. Quantum. Teleportation transfers information, not matter, from one location to another. This is not the beaming up of science fiction. It is not possible to teleport a physical object. Instead, quantum teleportation uses the principles of entanglement to transmit the complete information about a quantum state from one location to another. The process involves scanning the original particle, which destroys its state, and sending classical information to the receiving location, where that information is used to perfectly reconstruct the original state in another particle. It is a way of sending a perfect blueprint, not the building itself. Your circadian rhythm is an internal, 24-hour clock that regulates your sleep-wake cycle. Deep within your brain, in the hypothalamus, is a tiny cluster of nerve cells called the suprachiasmatic nucleus.
This is your body's master clock.
It generates a natural, near 24-hour rhythm that governs your cycles of sleepiness and alertness, hormone release, and body temperature. This internal clock is synchronized with the external world primarily by light, which is why exposure to light in the morning and darkness at night is so crucial for maintaining a healthy sleep pattern. You
Have a clock made of cells that is wound by the rising of the sun.
Universe's fundamental constants seem finely tuned to allow for the existence of conscious life. The values of constants, like the strength of gravity, the mass of the electron, and the dark energy density, appear to be set within an extraordinarily narrow range that is hospitable to life. If any of these values were even slightly different, the universe might have contained no stars, no planets, or no complex chemistry. This anthropic principle is either a sign of an incredible cosmic coincidence, evidence for a multiverse where all possible values exist, or a hint at some deeper, undiscovered principle governing the cosmos. The laws of physics seem to have been written with an audience in mind. The hippocampus is named after the Greek word for seahorse because of its shape. This vital brain structure, so crucial for memory and navigation, was given its name by an early anatomist who noted its curved, elegant shape in cross-section, which he thought resembled the graceful form of a seahorse. It is a small touch of poetry in the language of science, a name that links the seat of our most personal memories to a gentle creature of the sea. The The chamber of memory is named for a creature of the deep. Your brain creates a phantom sensation for a missing limb. After an amputation, a majority of people continue to feel vivid sensations, including pain, that seem to come from the missing limb. This is because the part of the brain's sensory map that was dedicated to that limb is still intact. Without any input from the limb, this area can become spontaneously active or be stimulated by signals from neighboring body parts, creating the powerful and very real sensation of a limb that is no longer there. It is a stark demonstration that what we feel is generated by the brain, not the body. The mind can remember a body that no longer exists. The energy of a single photon is determined by its frequency. A photon of light is a quantum, a discrete packet of energy. The amount of energy it carries is directly proportional to the frequency of its electromagnetic wave. A photon of red light, which has a low frequency, carries a small amount of energy. A photon of blue or ultraviolet light, which has a high frequency, carries a much larger amount of energy. This is the fundamental insight that launched the quantum revolution. The idea that energy is not a continuous fluid, but comes in these discrete, measurable packets. The color of light is the measure of its strength. Placebo effects demonstrate the powerful influence of belief on the brain's chemistry. A placebo is an inert substance, like a sugar pill, that can produce real physiological effects if the person taking it believes it is a real treatment. The placebo effect is not just in the mind. The belief in a treatment can trigger the brain to release its own endogenous opioids, like endorphins, which genuinely reduce pain. It can also influence levels of neurotransmitters like dopamine and serotonin. It is a powerful example of how our thoughts and expectations can directly and measurably alter our own biology. Belief is a form of chemistry, the information paradox in black holes. Questions whether information is truly lost forever. Quantum mechanics insists that information can never be destroyed. General relativity insists that anything that falls into a black hole can never get out. This creates a deep paradox. If a book falls into a black hole, is the information it contains wiped from the universe, violating quantum mechanics? Stephen Hawking famously argued that it was, but later changed his mind. The current thinking is that the information must be preserved somehow, perhaps encoded in the faint Hawking radiation that the black hole emits over billions of years. A black hole may be the universe's ultimate library, with a very slow return policy. The brain contains specialized cells for recognizing places, known as place cells. Located in the hippocampus, these remarkable neurons become active only when an animal is in a specific location in its environment. Different place cells fire for different locations, creating a neural map of the surrounding space. It is like having a fleet of tiny GPS trackers in your brain, each one dedicated to a particular spot in the room or a particular turn in a maze. These cells, along with other specialized neurons for direction and boundaries, form the cognitive map that allows you to navigate your world. Your mind builds a map of the world, one cell at a time. The transactional interpretation of quantum mechanics suggests waves travel both forwards and backwards in time. This is another attempt to solve the measurement puzzle. It describes any quantum interaction as a handshake across space-time. An emitter sends out an offer wave that travels forward in time. A potential absorber sends back a confirmation wave that travels backward in time. A transaction, a real quantum event, occurs only when this forward and backward wave meet and form a handshake. This elegant but strange picture eliminates the role of the observer and the collapse of the wave function, but at the cost of accepting causation that runs in both temporal directions. A quantum event is a conversation between the future and the past. The Human Connectome Project aims to map the entire network of connections in the brain. This monumental scientific endeavor is an attempt to create a complete wiring diagram of the human brain. The goal is to map every one of the trillions of synaptic connections between its billions of neurons. Such a map, or connectome, would be an invaluable resource for understanding how the brain functions and how its connectivity is disrupted in various neurological and psychiatric disorders. It is a task of almost unimaginable complexity, an attempt to chart the most intricate network in existence. It is the project of creating the ultimate map of the self. Dark energy is the name given to the mysterious force causing the universe's expansion to accelerate. While dark matter is the invisible gravity that holds galaxies together, dark energy is an even more enigmatic force that seems to be pushing everything apart. It appears to be a property of the vacuum of space itself, a constant low-level energy density that acts as a kind of anti-gravity. As the universe expands, more space is created and thus more dark energy, which causes the expansion to speed up even more. Its existence points to a new and unknown physics, and it will ultimately determine the final fate of our universe. It is a silent, persistent whisper telling the universe to grow. The boundary between you and the universe is, at a quantum level, entirely porous and undefined. We have a strong sense of ourselves as separate, bounded individuals. But at the most fundamental level, you are a collection of quantum fields, constantly interacting with the quantum fields of the air you breathe and the light that falls on your skin. There is no hard line where you end and the rest of the universe begins. You are a temporary, self-organizing pattern in the ceaseless flow of universal energy and information, a complex wave on the surface of the cosmic ocean.
Inextricably connected to the whole, you are not in the universe. You are a way the universe is experiencing itself, and so
Our quiet journey through the mystery of the quantum mind draws to a close. Our exploration of the strange and luminous landscape where thoughts and particles meet now settles into a deep and profound stillness. The echoes of these wonders can now begin to fade, leaving only a sense of peace in their wake. There is nothing left to learn, nothing left to understand. It is time to let it all go. We have drifted through clouds of pure possibility, through galaxies of neurons firing in silent symphony. We have considered the idea that the solid world is woven from threads of information, and that our own consciousness might be a way for the universe to look back upon itself. We have wandered through the borderlands where physics becomes philosophy and where the most advanced science leads us back to the most ancient questions of who we are. Let the feeling of this immense and intricate connection be a comfort to you now. The same quantum uncertainty that governs the heart of a distant star is the very canvas upon which your next dream will be painted. The atoms that make up your physical form were forged in stellar explosions billions of years ago, linking you in a real and tangible way to the entire history of the cosmos. You are a part of this strange, beautiful, and mysterious universe. You belong here, and now there is only one thing left to do. As you drift down into the soft depths of sleep, let these thoughts dissolve like sugar in water. Let the idea of the quantum world be a comfort, a sign that reality is deeper, richer, and more wondrous than we can imagine. Your only task now is to rest, to let go of the day, to allow your mind to become as calm and quiet as the vast, empty spaces between the stars. May your dreams be peaceful and profound. Good night.